Children's Planet Earth Encyclopedia. Children's Planet Earth Encyclopedia. By Jen Green. Introduction. From space, Earth looks like a big blue ball with white clouds drifting over it. Our world has just the right conditions for plant and animal life to survive. The sun lights and warms Earth. Water fills the rivers and oceans, and the air contains a gas called oxygen, which animals need to breathe. This book will explain all about Earth, its rocks and soil, mountains, valleys, rivers, and oceans. You can find out about earthquakes and volcanoes, and also learn about the different kinds of weather on our planet. At the back of the book is a list of useful words that will help you to understand any difficult words. Our Earth. Our home, planet Earth, is a rocky ball whizzing through space as it circles the Sun. Earth is the only planet we know of that has life. This chapter explains all about how Earth works. You can find out what causes day and night and why the seasons happen. It explains how Earth formed and how life began and developed. Read on to find out why some parts of Earth are cold, while others are hot. Our solar system. Earth is one of 9 planets circling the Sun. The Sun, its 9 planets, and smaller rocks make up a family called the solar system. Earth and the other planets follow paths called orbits as they circle the Sun. The planets. Earth is the 3rd planet from the Sun, after Mercury and Venus. Earth is the 5th biggest planet, but all the planets are tiny compared to the Sun. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. The Sun. The Sun is our local star. It is an enormous fiery ball shooting light and heat in all directions. The Sun's rays light and heat Earth. Without the Sun's warmth and energy, no living things could survive on Earth. Earth. Earth looks blue from space because it is mainly covered by oceans. The equator is an imaginary line that divides Earth into 2 halves called hemispheres. The poles are the places farthest north and south on Earth. North Pole. Equator. South Pole. Did you know? Earth moves at more than 62,140 miles, 100,000 kilometers, an hour as it circles the Sun. Each year, it travels nearly 584 million miles, 940 million kilometers, to complete a full circle. Stars. All the stars in the night sky are suns, like our Sun. Believe it or not, our Sun is just one of 100 billion stars in our part of the universe. Our Sun belongs to a huge group of stars called the Milky Way. Spinning Earth. Earth seems still, but, in fact, our world is spinning as it circles the Sun. This spin is called rotation. It takes 24 hours to complete one full rotation, which we call a day. Day and night. Earth rotates around an imaginary line called the axis, which joins the north and south poles. When Earth turns into the sunlight, it is day where you live. When Earth turns out of the sunlight, it is night. Direction of rotation. Nighttime. Axis. Daytime. Sunlight. Daytime. When the day begins, the Sun seems to rise in the east. It then moves across the sky and sets, or goes down, in the west. However, the Sun isn't really moving. Earth's rotation produces this effect. When an object blocks the sunlight, it makes a shadow. When you wave, your shadow waves, too. Nighttime. When it is dark, your part of Earth faces away from the Sun. The moon and stars shine in the darkness. The moon has no light of its own but is lit up by the Sun. Active at night. People and many animals are awake and busy by day when the Sun shines and we can see clearly. We sleep at night when it's dark and we can't see much. Some animals, such as owls, hunt at night. The owl's large eyes help it to hunt in dim light at dusk or by moonlight. Did you know? The Sun is about 93 million miles, 150 kilometers, from Earth. It takes just over 8 minutes for sunlight to reach Earth. Light travels at more than 186,400 miles, 300,000 kilometers, per second. Earth's orbit. As you sit still reading this, Earth is racing on its orbit, or journey, around the Sun. It takes 365 days to complete one full orbit. We call this a year. Earth tilts, and this produces the regular changes we call the seasons. Earth's tilt. Earth leans over as it rotates and orbits the Sun. This tilt carries you nearer or farther from the Sun at different times of year. Axis. The seasons. As Earth orbits the Sun, the northern half leans toward the Sun and has summer. The southern half leans away and has winter. 6 months later, Earth leans the opposite way, and the seasons are reversed. Earth. Equator. Sun. Axis. Direction of orbit. Summer in north. Winter in south. Winter in north. Summer in south. Spring. In spring, your part of Earth starts to lean toward the Sun. The days get longer and the weather warms up. Flowers bloom and trees grow new leaves. Daffodils are spring flowers. Summer. Days are long and nights are short in summer. Your part of Earth tilts toward the Sun. This is the hottest season. Fall. In fall, your part of Earth begins to lean away from the Sun. Days get shorter and nights get longer. The weather grows colder. In fall, some leaves change color and fall off the trees. Winter. Winter brings long nights and short days. This is the coldest season. The part of Earth where you live is tilted away from the Sun. Did you know? The seasons are most noticeable at the poles. This is because these parts are most affected by Earth's tilt. Forces on Earth. Earth's huge size and weight make it pull objects toward it. This pull, called gravity, prevents you and everything else on Earth from flying off into space. The Moon. Earth's gravity keeps the Moon orbiting around it. The Moon also has gravity, which tugs at the oceans on Earth. Earth. Moon. Orbit. Gravity. Earth's gravity causes anything you drop to fall to the ground. All huge, heavy objects, such as planets, have gravity. The Sun's gravity is very strong. It keeps Earth and other planets in the solar system rotating around it. However high you jump on a trampoline, the pull of gravity will bring you back to Earth. Magnetic pull. Scientists believe that iron inside Earth makes it magnetic. It acts like a giant bar magnet. The two ends of the magnet are the north and south poles. Earth's magnetic pull reaches far out into space. Tiny pieces of iron called filings are pulled toward this bar magnet, showing its magnetic field. Which way is north? Earth's north and south poles have a very strong magnetic pull. A compass contains a magnetic needle that points to the north. It can be used to help people find their way if they are lost. Did you know? The area affected by a planet's magnetic pull is called its magnetic field. Earth's magnetic field stretches 37,300 miles, 60,000 kilometers, into space. How Earth formed? Earth is incredibly old. Scientists believe the Sun and planets began to form about 5 billion years ago. Our solar system developed from a cloud of gas and dust spinning in space. The solar system forms. Gas in the center of the spinning cloud formed the Sun. Parts of dust stuck together to make rocks. These crashed and stuck together to make rocky planets, including Earth. Meanwhile, the Sun's gravity kept the planets rotating around it. Pieces of rock orbiting the Sun crashed together to form larger rocks and planets. The Sun. Early Earth. The young planet Earth was a fiery ball of hot, liquid rock. The heat came from all the rocks that had crashed together. Heavy rocks sank to the planet's center. Lighter rocks floated to the surface. There, they gradually cooled to make a crust. Rocks from space. The early Earth had no atmosphere to shield it from space. Giant rocks called meteorites crashed to the planet's surface. They made large hollows called craters. Meteorite crater in Arizona. Volcanoes everywhere. About 4 billion years ago, Earth's surface was dotted with volcanoes, see pages 64 to 75, erupting hot lava. Gas and steam from the volcanoes formed Earth's first atmosphere. The steam formed clouds, which dropped rain. The water collected in hollows, which eventually became the oceans. Earth facts. Earth's inside is still hot, liquid rock. The outside has cooled and hardened to make a solid crust. Earth is not perfectly round. It bulges slightly in the middle and is flatter at the poles. Earth is tiny compared to the Sun. You could fit more than 1,000,000 Earths inside the Sun. Life begins and changes. Scientists believe that life began on Earth about 3.8 billion years ago. Over millions of years, living things very slowly changed to suit their surroundings. These changes are called evolution. First life. The first living things appeared in the oceans. They were tiny, simple creatures called bacteria, made of just one cell. Much later, tiny plants called algae developed in the sea. These bacteria are shown many times larger than actual size. Plants make oxygen. The algae used the sun's energy to grow. They gave off oxygen. Some of these tiny plants grew in mounds called stromatolites. These mounds still grow in warm seas today. Stromatolite mounds in Australia. Animals appear. The first animals appeared in the oceans about 600 million years ago. They, too, were very simple creatures, with soft bodies. Gradually, animals developed more complicated bodies made up of many cells. Some, such as sea creatures called trilobites, developed hard shells. Trilobites had many legs. Feeler. Did you know? Trilobites were probably the first animals to have eyes. They also had feelers on their heads, which they used to search for food. Life moves onto land. About 400 million years ago, the first animals with backbones appeared. They were fish. Gradually, many different types of fish evolved. Some developed fleshy fins and crawled out of the water to live on land. Mudskippers are fish that can move about on land. Fossils. Fossils are the remains of plants and animals that lived and died millions of years ago. The remains have been preserved, usually as rock. Scientists discover all about prehistoric life by studying fossils. Ammonite. This is a fossil of an ammonite. Ammonites were creatures with shells that swam in the oceans millions of years ago. The living animal had tentacles that stuck out of its coiled shell. The hard shell of this ammonite has turned to rock. How ammonite fossils formed. When the ammonite died, it sank to the seabed. The soft parts rotted away, and the shell was buried by sand. Over millions of years, the sand slowly hardened into rock. Minerals seeped into the shell, until it, too, became rock. Dead ammonite sank to the seabed. Ammonite and sand slowly turned to rock. Amber. Amber is a different kind of fossil. The clear, yellow material is fossilized tree resin, a sticky sap that oozed from prehistoric trees. Insects got trapped in the sap, which then hardened to make a fossil. You can see the insect's delicate legs and wings in this fossil. Amber fossils may be up to 90 million years old. Fossil fern. The print of a fern leaf has been preserved in this rock. Ferns like warm, damp conditions. They grew well in the steamy prehistoric forests 300 million years ago. Prehistoric life. Since life began, many amazing animals have lived on Earth. We call the long period from 230 million years ago to 65 million years ago the age of reptiles. During this time, giant reptiles ruled the land, sky, and sea. Dinosaurs. A group of reptiles called dinosaurs were a terror on the land. There were many kinds of dinosaurs. Some were only as big as cats. Others were the size of jumbo jets. Some dinosaurs were meat eaters, while others ate only plants. Tyrannosaurus rex was a fierce meat-eating dinosaur. Swimming and flying reptiles. Other huge reptiles swam in the oceans. Plesiosaurs had long, snake-like necks and feet shaped like paddles. Another group of reptiles, the pterosaurs, soared through the skies on skin-covered wings. Plesiosaurs swam using their feet as paddles. Dinosaur fossils. This scientist is uncovering the skeleton of a dinosaur. He is chipping away the rock to reveal the fossil. Dinosaur bones have been found all over the world. Experts also find dinosaur tracks, and even dinosaur dung. Dinosaurs die out. The dinosaurs and other giant reptiles died out 65 million years ago. Experts believe a giant meteorite, or space rock, smashed into Earth, causing a huge dust cloud to block the sun for years. As a result, many plants died and there was not enough food for the dinosaurs. The meteorite exploded when it hit Earth. The disaster made Earth's climate change suddenly. Did you know? The largest dinosaurs measured about 72 feet, 22 meters, long. The ground shook when they walked. The very biggest dinosaurs were plant eaters. There are no dinosaurs living today. Earth's climate. Climate is the regular pattern of weather. Each part of Earth has its own climate. The sun has a big effect on the climate, but so do mountains, the seas, and cities. Heat from the sun. The sun's rays are overhead or nearly overhead in the region around the equator, which has a hot, tropical climate. At the poles, the sun's rays spread over a wider area, so they have less heating power. This means that the poles have a cold climate. Sun's rays. North Pole. South Pole. Equator. Tropic of Cancer. Tropic of Capricorn. Coastal climates. Many places by the sea have a mild climate. Temperatures stay fairly steady there because sea breezes cool the land in summer and warm it in winter. Did you know? The sea warms up and cools down more slowly than land, keeping temperatures on the coast steady. Many places far inland have very hot summers and very cold winters because they are far from the sea. Cool heights. Mountains usually have a cold climate. The air high on mountains cannot hold as much of the sun's heat as the air at sea level. The tops of high mountains are covered with ice and snow all year round. Clouds bring rain to mountains. City climates. Cities only cover a small area of the planet, but they have their own climate. Buildings and roads soak up the sun's heat by day and give it out at night. This makes cities warmer than the nearby countryside. Climate zones. A region's climate affects the plants and animals that live there. Large areas of Earth's surface have the same types of plants growing there. These regions are called biomes. Earth's biomes. You can see the world's main biomes on this map. The types of plants that grow in each place depend on how warm it is and how much rain falls. Hot, rainy places have many types of plants. Fewer plants grow in cold or dry places. Key to biomes. Mountains. Tropical rainforests. Temperate woodlands. Evergreen forests. Tropical grasslands. Temperate grasslands. Tundra. Deserts. Polar. North America. South America. Africa. Europe. Asia. Australasia. Antarctica. The Arctic. Tropic of Cancer. Equator. Tropic of Capricorn. Deserts. Deserts are very dry places where less than 10 inches, 25 centimeters, of rain falls each year. Some deserts get no rain at all for years. Deserts may be sandy, rocky, or stony. Many are boiling hot by day and freezing cold at night. Temperate zones. Temperate regions lie between the poles and the tropics and have a mild, rainy climate. In temperate woodlands, most trees lose their leaves in fall. Temperate woodland in fall. Cold forests and tundra. In the cold northern forests, trees stay green all year. Little grows in the icy tundra except during the short summer. The ground beneath the surface stays frozen all year. Plants bloom during the short tundra summer. Hot climates. Places on the equator and in the tropics have hot climates. It is warm there all year round, and nights are never frosty. Snow only falls on the tops of the very highest mountains. Hottest places. Dalal in East Africa has the hottest average temperature on the planet. It stays at about 93 degrees Fahrenheit, 34 degrees Celsius. Death Valley has some of the highest temperatures ever recorded, up to 132.8 degrees Fahrenheit, 56 degrees Celsius, but it does not stay that hot all the time. Death Valley is a desert in the western United States. Did you know? In 1922, the city of Al-Aziz Zia in North Africa had the highest temperature ever recorded on Earth, an incredible 135.9 degrees Fahrenheit, 57.7 degrees Celsius. 2 seasons. Earth's tilt affects the tropics very little, so there is no spring, summer, fall, or winter. But some tropical places have 2 seasons, a dry and a rainy season. India has its wet season from April to September every year. Lush rain forests. Rain falls almost every day on most places at the equator. Rainforest trees love the hot, damp conditions. More types of plants and animals live in tropical rainforests than in any other biome. Hot grasslands. Tropical grasslands grow in places that get less rain than rainforests but more rain than deserts. These areas are home to many grass-eating animals, such as zebras and antelopes, and the animals that feed on them, such as lions. Lions live on the tropical grasslands in Africa. Cold climates. The regions surrounding the North and South Poles are the coldest places on Earth. The sun's rays have little warmth there. Most land in the polar regions is covered by a thick layer of ice and snow. Shimmering lights. Swirling curtains of light sometimes shimmer in the night sky at the poles. These beautiful lights are called auroras. The lights may be red, green, or purple. This amazing display is caused by particles from the sun hitting gases high in the air. Midnight sun. In summer, each pole tilts toward the sun. At night, the sun dips low in the sky, but never sets. So it stays light, even at midnight. In winter, the pole leans away from the sun. The sun never fully rises, so it is dark all the time. The sun shines all night in summer at the poles. The Arctic. The area around the North Pole is called the Arctic. This region is mainly an ice-covered ocean. Polar bears and seals live in the sea and on the ice. This polar bear is hunting seals on the ice. Antarctica. The area around the South Pole is called the Antarctic. The vast icy land of Antarctica lies in this area. Antarctica is covered with a thick cap of ice up to about 1 3/4 miles, 3 kilometers, deep. Penguins and seals live only on the coast. Penguins have thick feathers and a warm, fatty layer under their skin. Did you know? Vostok Base in Antarctica is the coldest place on Earth. Scientists recorded a temperature of -128.2 degrees Fahrenheit, -89 degrees Celsius, there. Rocks and soil. This chapter explains how rocks form and how the rocks at the surface are broken down by rain, wind, frost, and sunlight. Underground, there are many riches, such as gold, silver, and diamonds. Valuable fossil fuels, coal, oil, and gas, come from beneath the ground, too. However, soil, which lies on top of Earth's rocky surface, may be the greatest treasure of all. Read on to find out why. Rocky planet. We live on Earth's hard, rocky surface called the crust. Deep below the crust, the rocks are hot, so hot they are melted and flow like sticky molasses. Inside Earth. Scientists believe Earth is made of several layers. The surface crust is thin, like the shell of an egg. Below the crust is a thick layer called the mantle, with red-hot rocks. In the core at the center, the rocks are even hotter. Cross-section through Earth. Crust. Mantle. Outer core. Inner core. Did you know? Scientists believe the temperature at the center of Earth is more than 9,000 degrees Fahrenheit, 5,000 degrees Celsius. The outer core is made of partly liquid rock. The inner core is a solid ball of metal. Heat from below. Deep mines are hot because of the hot rocks below. But even the very deepest mines are just like a pinprick in the giant rocky ball that is Earth. This man is working in a hot, deep mine. Rocky crust. Cliffs and mountains are formed from Earth's crust. If you stripped away the grass, soil, or concrete at any place on Earth, you'd hit rock. These cliffs were made by a river cutting through the rock. Earth's rocky crust at the Grand Canyon. Ocean crust. Earth's crust is thicker beneath the land than beneath the oceans. The crust beneath the land is 12.5 to 56 miles, 20 to 90 kilometers, thick. Beneath the oceans, it is only about 4.5 miles, 7 kilometers, thick. Land. Ocean. Thin crust. Thick crust. Fiery rocks. Rocks form in different ways. Fiery rocks come from deep underground. Red-hot, liquid rock bubbles up to near the surface, then cools to form solid rock. Glowing lava. Red-hot, liquid rock deep underground is called magma. When it spills onto the surface at a volcano, see pages 64 to 75, it is called lava. Lava cools and hardens quickly at the surface. Frothy pumice. A type of rock called pumice was once frothy lava. Like froth on a soft drink, it contains air bubbles. The bubbles were trapped when the lava cooled. Bubbles make this rock so light it floats on water. People use pumice to rub away hard skin while bathing. Giant's Causeway. Basalt is a hard fiery rock. Volcanoes on the seabed erupt melted basalt. The red-hot lava cools quickly when it hits the water. The Giant's Causeway in Northern Ireland is made of basalt pillars. These formed when the lava cooled quickly, shrank, and cracked. Six-sided basalt pillars. Did you know? The rocky pillars at the Giant's Causeway mainly have 6 sides. Legend says a giant laid the rocks as stepping stones. Granite. Granite is another hard fiery rock. It forms where magma rises but cools before it reaches the surface. This hard stone is used for making buildings and roads. Granite building in Scotland. Wearing away. The rocks at the surface are battered by rain, wind, frost, and sunshine. Parts of rock flake off and are carried away by wind and water. This process is called erosion. Eating into rock. Rainwater contains a weak acid that eats into soft rocks, such as limestone. This is similar to when an aspirin dissolves in water. The rainwater slowly wears deep grooves in the rock. This flat slab of limestone is crisscrossed with deep grooves. Shattered by ice. In cold places, such as on mountainsides, water seeps into cracks in the rock and freezes at night. Ice takes up more space than water, so the ice widens the cracks. Eventually, the rock flakes away. Ice has made this rock crack. Worn by wind. In dry, windy places, sand and grit are carried on the wind. When the wind blasts against rock, the sand and grit act like sandpaper. This can carve smooth curves into the rock. This rock in Western Australia is called wave rock. Carried away. When it rains, trickling water carries away small pieces of loose rock. The water drains into streams and rivers, which carry the rocky pieces downhill. They end up in seas or lakes. Did you know? Erosion usually happens very slowly. However, sometimes a large amount of rock slips away at once. This is called a landslide. Settled rocks. Fiery rocks are not the only type of rock. Another type forms from rocky pieces that are carried out to sea by rivers. The pieces get squashed together by more rocky fragments and eventually turn into solid rock. Rock layers. When the rocky pieces are carried out to sea, they settle in layers on the seabed. Later, the rock layers may be pushed upward when mountains form, see pages 90 to 91, and become part of the land. You can see the rock layers in this sandstone cliff in New Zealand. Clay pots. Clay is a rock that is soft when wet. Potters shape clay to make pots. The pots are baked in an oven to make them hard. These children are helping to make a clay pot. Pudding stone. A rock called conglomerate contains round pebbles that settled on the seabed. When the layer was squashed, the pebbles stuck together. Conglomerate, also called pudding stone, can be made up of large rocks as well as pebbles. Chalk. Chalk is a soft, white rock made of the tiny shells of millions of sea creatures. The shells built up on the seabed and were later buried. The shelly layer very slowly turned to chalk. This rock can be used to draw on blackboards and paved areas. These cliffs are made of chalk. Did you know? Fossils, the remains of ancient plants and animals, are often found in layered rocks, such as sandstone and limestone. Changed rock. Changed rocks are another type of rock. They form when rocks are heated or squeezed below ground. The rocks may be squeezed by other rocks on top of them, or they may be squeezed by magma rising upward, which can also heat the rock. Heated rock. This is a changed rock called gneiss. The wavy lines show where the rock layers have been melted and squeezed. Sometimes squeezing happens when rocks shift underground during earthquakes, see pages 76 to 85. Slate. Slate forms when a rock called shale is squashed deep below ground. Slate naturally splits into thin sheets that make great roof tiles. Marble. Marble forms when limestone rock is heated underground. Heating and squeezing make the rock change color and texture. Marble can be carved easily and its surface polished until it shines. The Taj Mahal. The Taj Mahal is a beautiful palace in northern India. It is made of white marble and decorated with colored marble. Marble comes in several colors: black, pink, green, and white. Some marble has swirling patterns. The dome is made of marble blocks of different colors. Did you know? Marble is a changed rock. Some of the world's most famous sculptures have been carved from this rock. Bryce Canyon. Bryce Canyon is a national park in the western United States. It is formed of layered rocks called sandstone, limestone, and mudstone. Over time, water, ice, and wind have carved fantastic shapes into the rocks. Wildlife Park. Animals, such as deer and foxes, live in Bryce Canyon. Some use the rocks for shelter. There are also birds, such as swallows, ravens, and eagles. A bald eagle's wings can measure 8 feet, 2.5 meters, across. Hoodoos. The tall rock spires of Bryce Canyon are called hoodoos. These rocky pillars are made of soft mudstone topped with harder limestone. Ice and water wear the soft mudstone away more quickly than the harder cap of rock. Water, ice, and wind wear grooves in the rock. Colorful rocks. The rocks of Bryce Canyon are pink and orange. The minerals iron and manganese give the rocks their color. At sunrise and sunset, the rocks glow bright red. Rock Arch. Thunderstorms and hailstorms can strike Bryce Canyon in summer. Snow and ice cover the ground in winter. Rain, hail, snow, and ice wear away the rocks to make amazing features, such as this arch below. Bryce Canyon Facts. The rocks of Bryce Canyon formed on the beds of lakes and rivers. Over time, the forces that build mountains lifted the rocks 8,200 feet, 2,500 meters, above sea level. Bryce Canyon has more hoodoos than almost any place on the earth. Did you know? Bryce Canyon became a national park in 1928. The park covers about 56 square miles, 145 square kilometers. The hoodoos of Bryce Canyon are up to 197 feet, 60 meters, tall. Minerals. Rocks are made of natural materials called minerals. There are thousands of different minerals but only about 100 are common. Granite. Granite is made up of 3 different minerals: quartz, mica, and feldspar. They can be seen in this close-up photograph. Granite is used as building stone. Feldspar. Mica. Quartz. Plaster from gypsum. If you break an arm or a leg, the doctor will put a plaster cast on it while it heals. Plaster is made of a soft mineral called gypsum. The wet plaster sets to make a hard cast. Wet plaster is molded around the leg. Copper mines. Valuable minerals, such as copper, are dug from mines. Many mines run deep below ground, but copper is often found near the surface. Copper is used to make water pipes and electrical wire. Fireworks. Fireworks, such as sparklers, are made from a yellow mineral called sulfur. Sulfur is also used to make matches and explosives. Next time you see a firework display, remember sulfur. Did you know? The soft mineral graphite is used to make the lead in pencils. Crayons and paints can be made using another soft mineral called talc. Metals. Strong, shiny metals can be worked into different shapes. Metals are found in rocks called ores, often mixed with other minerals. Rare metals, such as gold, are expensive. Gold. Gold is usually found in rocks deep below ground. But a few lucky people have found whole lumps, called nuggets, at the surface. Specks of gold are sometimes washed out of rocks by water, and are found on riverbeds. Lump of gold ore. Gold wedding ring. Did you know? The largest gold nugget ever found weighed 154 pounds, 70 kilograms. It was found in Victoria, Australia, in 1869. The lump was nicknamed the Welcome Stranger. Silver. Silver is another rare metal found in an ore. Ores are usually crushed and heated to get the metal out. Silver is sometimes used to make coins. These silver coins come from ancient Greece. Gold rush. When someone discovers gold, thousands of people rush to the same area, hoping to get rich. This is called a gold rush. Gold in river gravel is collected by swirling the gravel around in a pan. The gold sinks to the bottom. This is called panning. A miner panning for gold in California in 1890. Making iron. Iron is made by heating iron ore in a hot furnace. Limestone and coke, a type of coal, are also added. Hot, liquid iron runs out at the bottom of the furnace. Iron is used to make an even stronger metal called steel. Red hot, runny iron flows from the furnace into a container. Gems and jewels. Minerals called gemstones are made into jewels. Experts cut and polish the stones until they sparkle. There are more than 50 different kinds of gemstones. They are all rare, but some are very rare. Rough diamond. A diamond forms when a material called carbon is heated and squeezed very hard underground. Diamonds do not have much sparkle when they come out of the ground. Many sides are cut into the stone to make it sparkle. Uncut diamond. This diamond has been cut and polished so it sparkles. Did you know? Diamonds are the hardest mineral found on Earth. They are used to make cutting tools as well as jewels. Crystals. Most gemstones form as even-sided crystals. Each type of crystal has a regular shape with a certain number of sides. You can see the large, purple crystals in this chunk of amethyst. Many colors. Gemstones come in many beautiful colors. Sapphires are blue, emeralds are bright green, and rubies and garnets are dark red. Opals have many colors. They are not cut with many sides but are smoothed and rounded. Most large opals come from Australia. Crown jewels. The crown of the British king or queen has more than 3,000 jewels. One of the largest stones is a famous diamond called the Cullinan II diamond. The largest red stone is called the Black Prince's ruby. Fossil fuels. Most of the energy we use at home comes from coal, oil, and gas. They are formed from fossils, the remains of prehistoric plants and animals. That's why we call them fossil fuels. Coal mining. Coal is usually found deep below ground in layers called seams. A deep hole called a shaft is dug to reach the coal. Coal is burned in power stations to produce electricity for homes and factories. A lump of coal. How coal was made. Coal formed when prehistoric plants from swampy forests died and sank into the swamp. They were squashed as soil and rock built up on top and slowly hardened into peat, a type of soil. The peat then slowly hardened into coal. Peat slowly turned to coal. Dead plants were squashed to make peat. Ferns and trees grew in prehistoric forests. Oil and gas. Oil and gas are the remains of tiny sea creatures that were buried and squashed on the seabed. They slowly turned to oil and gas. These fuels are mined from the seabed by drilling deep holes. Oil is made into fuel for cars. Gas is used for cooking and heating. Cars burn fuel to power their engines. Did you know? When cars, factories, and power stations burn fossil fuels, they give off waste gases that cause pollution. The pollution is making the world's climate warmer. Find out more about this on pages 212 to 213. Made from oil. Oil has many uses. Plastic and nylon are made from the leftovers when oil is purified. Paint, lipstick, and candles are also made from oil. All these plastic objects are made from oil. Soil story. You may not think of soil as valuable. But in a way, soil is even more precious than gold, oil, or diamonds. Plants need soil to grow, and animals need plants for food. So most living things depend on soil. How soil is made. Soil is made from tiny parts of rock mixed with plant and animal remains. Soil begins to form as ice, water, and wind break rocks into pieces. Plants take root in the rocky pieces. Rotting plants and animal remains make the soil richer. Soil layers. Soil contains several layers. At the very top is a thin layer of rotting plants called humus. The rich topsoil contains plant and animal remains. The subsoil below contains broken rocks. At the bottom is solid bedrock. Humus. Topsoil. Subsoil. Bedrock. Tree roots. Trees spread their roots through the soil. The roots draw water and nourishing minerals from the soil. They also anchor the tree in windy weather. Roots break up rocks to form more soil. Different soils. There are many types of soil. Sandy and chalky soils are dry and powdery. Clay soil is sticky. Different plants like different types of soil. Gardeners need to choose the right plants for the soil in their garden. Did you know? It takes hundreds of years to form even a thin layer of soil. Soil is much deeper in some places than others, it may be anything from a few inches to several feet deep. Life in soil. Soil contains thousands of different living things, from tiny insects and spiders to earthworms and larger animals, such as moles and rabbits. The crops that provide our food grow in soil. Animal burrows. Earthworms and moles burrow in the soil. Their tunnels let air and water in. This helps to make the soil more fertile. Worms and moles spend their lives under the ground. Eat and be eaten. Living things in the soil depend on one another for food. Earthworms feed on rotting leaves. Moles feed on earthworms. When animals die, their remains nourish the soil, which helps more plants to grow. Moles shovel away the soil using their powerful front claws. Plowing the soil. Farmers prepare the soil for growing crops by plowing. This turns the soil over and helps air and water reach the lower layers. The plow can be pulled by a tractor, or by animals such as oxen or horses. These oxen are pulling a plow in India. Harvest time. Farmers harvest crops when they have grown and ripened. Some farmers cut the crop by hand. Others use machines called combine harvesters to cut and gather the crop. This combine harvester is pouring ripe grain into a truck. Did you know? Scientists say that every cubic yard, meter, of soil contains at least 1 billion living things. Most of these are so small you would need a microscope to see them. The violent earth. Volcanoes and earthquakes are two of nature's scariest wonders. Rivers of hot, melted rock gush from an erupting volcano. Ash, rocks, and gas blast high in the air. During an earthquake, the ground heaves and houses, trees, and bridges collapse. Earthquakes and volcanoes happen because of powerful forces underground. Read on to find out when, where, and why earthquakes strike and volcanoes erupt. Earth's crust. Earth's hard outer crust sits on top of red-hot, squishy rock. The crust is not one solid layer but is made of giant slabs of rock. The huge slabs are called plates. Moving plates. Earth's plates fit together like pieces in an enormous jigsaw puzzle. Currents in the melted rock below cause the plates to drift very slowly. These movements produce earthquakes and volcanoes on Earth's surface. These yellow lines show the edges of Earth's plates. North America, South America, Africa, Europe, Asia, Australasia, Antarctica. Faults. As Earth's plates move very slowly across the surface, they bump and scrape one another. Where two plates scrape together, a long crack called a fault sometimes appears. A fault at the point where two plates meet in Iceland. Volcanoes. Earth's crust is thin and weak where the plates meet. Red-hot, melted rock wells up from below, breaks through, and spills out onto the surface. We call these places volcanoes, see pages 64 to 75. Earthquakes. Plates moving past each other sometimes jolt violently. The jolt, which makes the ground shake, is called an earthquake, see pages 76 to 85. Earthquakes can do great damage. An earthquake has made this building in Japan collapse. Did you know? Earth's plates move very, very slowly. They shift about 1 inch, 2.5 centimeters, each year. People's fingernails grow at about the same rate. Volcanic eruptions. When melted rock known as lava spills out of a volcano, it is called an eruption. Lava rushes out in fiery rivers, then cools to form solid rock. It slowly builds up in layers to form a mountain. Inside a volcano. Red-hot rock inside Earth is called magma. Magma builds up below the volcano in a magma chamber. As more magma rises, the pressure builds up. Red-hot lava, ash, gas, and steam burst out through the top of the volcano. Ash. Crater. Magma. Lava. Magma chamber. Flying rocks. Some volcanoes shoot chunks of red-hot rocks high in the air. The hot rocks fly through the air and then splatter on the ground. These deadly rocks are called lava bombs. Hollow crater. The opening in the top of the volcano is called the crater. As the eruption dies down, the large hole is blocked by ash and solid lava. These shoot out with great force the next time the volcano erupts. Lava shoots out of the crater of a volcano in Hawaii. Glowing clouds. During some eruptions, clouds of burning ash pour out of the volcano. These heavy clouds spill down the mountain, moving much faster than lava. They burn anything in their path. A huge cloud of ash erupts from Mount Mayon, a volcano in the Philippines. Did you know? In 1815, a volcano in Southeast Asia called Mount Tambora shot millions of tons of ash into the air. The ash cloud drifted on the wind and spread all around the world. It was the most powerful eruption since records began. Types of volcano. The shape of a volcano depends on the type of lava that spills out of it. The two main types of volcanoes are tall, cone-shaped volcanoes and flatter shield volcanoes. Underwater volcanoes. Some volcanoes erupt under the sea. The hot lava cools as soon as it hits the water. This forms rounded lumps of rock called pillow lava. Cone-shaped volcanoes. Some volcanoes explode violently, throwing out thick, sticky lava. This type of lava flows only a short way before cooling and turning solid. Layers of lava and ash build up to form a cone-shaped mountain. A cone-shaped volcano in the Philippines. Shield volcanoes. Some volcanoes erupt runny lava. This lava flows a long way before cooling and turning solid. A low, rounded hill called a shield volcano eventually forms. A shield volcano on the islands of Hawaii. Sleeping volcano. Not all volcanoes erupt all the time. A volcano that has not erupted for a long time but may erupt again is called a dormant volcano. Dormant means sleeping. A volcano that has stopped erupting is called an extinct volcano. Snow covers the top of a dormant volcano in Africa. Did you know? Volcanoes that have erupted recently, or are still erupting, are called active volcanoes. There are more than 1,000 active volcanoes around the world, but only 20 to 30 actually erupt each year. Mount St. Helens. In May 1980, a volcano called Mount St. Helens in Washington suddenly erupted. The whole top of the mountain blew off in a violent explosion. Whoosh! When Mount St. Helens erupted, ash, gas, and steam escaped with an enormous whoosh. People living hundreds of miles away heard the explosion. A thick layer of ash rained down on the countryside. Before the eruption, Mount St. Helens had not erupted for 123 years before the 1980 eruption. The mountain looked peaceful, but inside the pressure was slowly building. Wrecked forests. Forests of tall trees covered the lower slopes of Mount St. Helens before the eruption. The blast snapped the trees like matchsticks. New life. After the eruption, Mount St. Helens looked lifeless. Ash lay thick on the ground and choked lakes and rivers. But after just a few months, plants began to sprout and animals returned to Mount St. Helens. Eruption facts. The cloud of ash from Mount St. Helens rose 12.5 miles, 20 kilometers, in the sky. The ash made the sky dark and drifted on the wind to settle over a wide area. Towns up to 185 miles, 300 kilometers, away were covered in ash. Mount St. Helens erupted violently for 4 days. Smaller eruptions continued for several months afterward. Famous eruptions. The most powerful eruptions do a lot of damage. When water or snow mixes with volcanic ash, it produces a tide of mud, which can destroy towns and villages. Mount Vesuvius. About 2,000 years ago, a volcano called Vesuvius erupted in southern Italy. The Roman town of Pompeii was buried under a thick layer of ash and was not discovered again for hundreds of years. Buried by ash. When hot ash rained down on Pompeii, many people died. The bodies of some people and animals left behind hollow spaces in the hard ash. A model of a dog made by pouring plaster into a hollow in the ash. Did you know? Experts believe more than 2,000 people died in Pompeii when Vesuvius erupted. The volcano had not erupted for a long time, so people had thought it was safe to live close by. Deadly ash. In 1991, Mount Pinatubo on the Philippines erupted, as ash covered the landscape. Heavy rain turned the ash to mud, which swept across the island. Several villages were buried by the mud. Tide of mud. In 1985, the Nevado del Ruiz volcano high in the Andes Mountains in South America erupted. Red-hot lava and ash melted snow on the mountain. A tide of mud roared downhill and buried the town of Armero in the valley below. Volcanic wonders. The heat from volcanoes creates amazing volcanic landscapes, which include hot springs and mud pools. The soil around volcanoes also makes good land for growing crops. Hot springs. In hot springs, the water is heated by hot rocks underground. People like to bathe in the warm water. Some monkeys in Japan bathe in hot volcanic springs to keep warm during the icy winter. Monkeys at the hot springs in Nagano, Japan. Useful volcanoes. Volcanic rock and ash break down to make rich soil for farming. This farmland is on the slopes of a volcano in the Philippines. Coconut trees and rice grow well in the fertile volcanic soil. Hot fountain. Water trickling underground may be heated by hot rocks. When the water reaches boiling point, it shoots upward, like steam from a steam train. The fountain of hot water is called a geyser. Steam from this geyser erupts high into the air. Bubbling mud. In some volcanic areas, water mixes with hot ash to make pools of bubbling mud. The mud is rich in minerals. Some people put volcanic mud on their faces and bodies because they believe it is good for their skin. Did you know? In Yellowstone National Park, Wyoming, a geyser shoots a jet of water every 72 minutes. The geyser is called Old Faithful. It can shoot up to 130 feet, 40 meters, high. Studying volcanoes. Nothing can stop a volcano from erupting. But experts can often tell when a volcano is about to erupt. They warn people to leave if they are in danger. Volcano experts. Scientists who study volcanoes are known as volcanologists. A volcanologist is taking a sample of lava from an eruption on Hawaii to learn more about the volcano. Fireproof suit and mask protect the scientist. Gas samples. These scientists are taking gas samples from a volcano. If there is more gas than usual, it may mean that the volcano is about to erupt. One volcanic gas, sulfur dioxide, smells like rotten eggs. Time to go. When people have to leave because a volcano is about to erupt, it is called an evacuation. These people are evacuating the island of Montserrat in the Caribbean because of danger from a nearby volcano. Keeping watch. If an eruption is about to happen, gas and steam may start to leak from a volcano. The mountain may bulge as melted rock builds up inside. The scientist, below, is checking the shape of Mount St. Helens in 2004 to make sure it is still safe. This huge crater was made by the 1980 eruption. Did you know? Some volcanoes still fool the experts by erupting without warning. In 1973, a volcano in Iceland suddenly started to spout red-hot lava. Everyone had thought the volcano was extinct. Earthquakes. The plates that form Earth's crust are always moving slowly. This puts the rocks below ground under great strain. An earthquake happens when the rocks suddenly jolt into a new position. Shock waves. Earthquakes usually start deep underground. The point where rocks grind and shatter is called the focus. Shock waves spread out in all directions. The damage is worst on the surface directly above. Epicenter is the point on the surface directly above the focus. Shock waves. Focus. Wrecked buildings. Powerful earthquakes make the ground shake. Buildings can be torn from their foundations. Glass shatters and steel beams bend like rubber. Houses sway and crash to the ground. Cracked ground. When an earthquake strikes, the violent shaking can make the ground split open. Huge cracks can appear in roads and sidewalks. Some cracks are big enough to swallow cars. This crack appeared in a road after an earthquake in California in 1989. Broken bridge. Strong earthquakes can damage roads and bridges. In 1995, an earthquake in Japan destroyed this highway. Wrecked roads and railroads can make it difficult for outside help to reach a region hit by an earthquake. Did you know? Thousands of earthquakes strike each year, but most are tiny. Small quakes make light bulbs swing and ornaments rattle. The most powerful earthquakes wreck whole towns. Effects of earthquakes. An earthquake lasts only a few seconds, but the shaking can do terrible damage. Earthquakes also start fires, cause landslides, and turn solid ground to mud. Fire. Fires start when gas pipes and electricity lines are damaged by earthquakes. In 1989, fire swept through San Francisco, California, after an earthquake. Water pipes were damaged by the earthquake, making it difficult for firefighters to put out the flames. Dam burst. Powerful earthquakes can destroy dams built on rivers. A wall of water then bursts through the dam and rushes down river. Towns and villages lower down are swept away. This dam in Taiwan was wrecked by an earthquake in 1989. Landslide. When the ground shakes, loose soil and rock can slip away in a landslide. This landslide happened after a quake in Central America in 2001. The landslide started on this hillside. Sinking ground. Violent shaking can turn clay or sandy soil to mud. Buildings sink into the mud or topple over. These buildings collapsed after an earthquake hit Niigata, Japan, in 1964. Did you know? In 1970, an earthquake in the Andes Mountains made a mass of snow slide off a high peak. A tide of mud, rock, and ice roared down the mountain and destroyed a town called Yungay. Tsunamis. Earthquakes can strike under the sea as well as on land. When an earthquake shakes the seabed, it can cause powerful waves called tsunamis. These waves race across the ocean and wreck towns when they reach the coast. 2004 tsunami. In December 2004, a powerful earthquake rocked the seabed off Indonesia in Southeast Asia. Strong waves spread out like ripples. The waves traveled 3,100 miles, 5,000 kilometers, to wreck towns on the shores of India and even Africa. Key to map. Areas hit by the tsunami. Epicenter. Waves spreading outwards. Africa. Maldives. Indian Ocean. India. Sri Lanka. Thailand. Malaysia. Indonesia. Krakatoa. Volcanic eruptions can also cause tsunamis. In 1883, a volcano on an island called Krakatoa, near Indonesia, exploded. The explosion set off tsunamis that spread far and wide. The waves swamped coastal towns, and 36,000 people died. Did you know? When Krakatoa exploded, the bang was heard 3,100 miles, 5,000 kilometers, away. The explosion destroyed most of the island, but flows of lava formed a new island. The new island was named Anak Krakatoa, which means child of Krakatoa. Towering waves. Out at sea, tsunamis form low waves that aren't very noticeable. But they build up to become much taller when they reach shallow water. The huge waves are a terrifying sight when they smash onto the shore. Wrecked coast. Damage from the 2004 tsunami was worst on the coast of Indonesia. Whole towns were completely flattened by the waves. Boats were swept onto the shore and carried far inland. All the buildings in this town in Indonesia were destroyed by the 2004 tsunami. Deadly earthquakes. Earthquakes can be incredibly destructive. The damage is often worst in cities, where many people are killed by falling buildings. Earthquakes have brought disaster to many parts of the world. Lisbon, 1755. In 1755, an earthquake struck out at sea near the city of Lisbon in Portugal. Huge waves wrecked Lisbon's harbour. Candles burning in churches and houses were knocked over and fires started all over the city. San Francisco, 1906. In 1906, a powerful earthquake wrecked the city of San Francisco in California. Fires broke out and raged for days because firefighters ran out of water. Did you know? San Francisco lies on a fault where two plates scrape past each other. This fault runs for about 750 miles, 1,200 kilometers, along the western coast of the United States. Earthquakes strike San Francisco often, in 1906, 1989, and 1994. Armenia, 1988. In 1988, a strong earthquake struck Armenia in Western Asia. The town of Spitak was destroyed. Around 50,000 people died, and many more lost their homes. Survivors in the ruined town of Spitak. Kashmir, 2005. In 2005, a powerful quake rocked the region of Kashmir, high in the Himalayas. Landslides destroyed roads and bridges, which made it difficult to rescue survivors. Helicopters had to be used to fly people to hospital. Watching earthquakes. Scientists use machines to measure the strength of earthquakes. If experts believe an earthquake is due, they warn everyone. But it is very hard to say exactly when and where an earthquake will strike. Measuring quakes. A seismograph measures the shaking caused by earthquakes. Pens attached to weights hang above a roll of paper. When an earthquake strikes, the paper shakes, and the pens draw zigzags on the paper. Bigger zigzags show bigger quakes. Animal warnings. Animals often act strangely just before an earthquake. Rats run away, while cats meow and dogs bark. Some experts believe that animals can hear the very high, faint noises made by rocks that are stretched to breaking point before a quake. Did you know? In 1975, scientists in the Chinese city of Haicheng noticed animals acting strangely. They ordered everyone to leave the city. A few hours later an earthquake struck. Safety practice. If an earthquake strikes, people should stay indoors and hide under a strong desk or table. This Japanese child is practicing what to do in an earthquake. She is wearing a padded hood to protect her head. Safer buildings. In areas where earthquakes are likely, people design buildings that will cope with the shaking. This tall building in San Francisco has strong steel beams to support it. The pyramid shape of this building helps it stay upright in an earthquake. Mountains and glaciers. Mountains are the highest places on the earth. This chapter explains how these rocky peaks form and describes some of the plants and animals that live there. Read on to find out about mountain dangers and about living in and visiting these high places. This chapter also explains what glaciers are and how they form. Towering mountains. Mountains are high, rocky areas that rise above their surroundings. Many mountains have steep, sloping sides, and the tops of very high mountains are cold and covered with snow. Mountain chains. Some mountains stand alone, but many form long lines called chains or are found in groups called ranges. The Andes in South America is the longest mountain chain on land, stretching for 4,475 miles, 7,200 kilometers. Andes. South America. The Himalayas. The Himalayas in southern Asia are the world's highest mountains. This range includes Mount Everest. At 29,078 feet, 8,863 meters, it is Earth's highest mountain on land. Snow-covered K2 is 28,251 feet, 8,611 meters, tall. Did you know? K2 in the Himalayas is the second highest mountain in the world. It is so hard to reach that it was never named by local people. It was called K2 by explorers in the 19th century. Rising from the ocean. Mountains are measured from sea level. Mauna Kea, a mountain in Hawaii, rises 13,795 feet, 4,205 meters, above the surface of the sea, but the rest of the peak lies underwater. Mauna Kea is taller than Mount Everest when measured from the seabed. Mauna Kea is 33,480 feet, 10,205 meters, from the seabed. Mauna Kea. Sea level. Pacific Ocean. Seabed. Africa's highest peak. Mount Kilimanjaro is the tallest peak in Africa. This mountain rises to 19,340 feet, 5,895 meters. The top is covered with snow, although Kilimanjaro is near the equator, where the climate is hot. Fold mountains. Many of the world's highest mountains are found in places where two plates of Earth's crust push against each other. Rocks are pushed upward, forming fold mountains. How fold mountains form? Fold mountain ranges form where two of Earth's plates crash together. The land in between the plates is pushed up and the rocks fold, forming mountain peaks. The Himalayas in Asia, and the Pyrenees and Alps in Europe, are fold mountain ranges. One Earth's plates push together. 2 rocks are pushed up. 3 range of fold mountains forms. Did you know? The Alps and Himalayas are still rising as rocks are pushed upward. In about 1,000 years, these mountains will be about a meter, taller than they are today. Zigzag rocks. As the layers of this rock in Great Britain were squashed, they folded to form these amazing zigzag patterns. Fold mountains in the Pyrenees in Spain. Volcanic mountains. Volcanoes are another type of mountain. These form when hot, melted rock erupts on Earth's surface. Layers of erupted rock build up to make tall, cone-shaped mountains. Cotopaxi is a volcanic mountain in Ecuador, South America. Blocks and domes. 2 other types of mountains are steep-sided block mountains and rounded dome mountains. All mountains take millions of years to form, but some are much older than others. Young mountains are usually much higher than old mountains. Block mountains. The movement of Earth's plates sometimes causes long cracks called faults to appear, see page 62. If a huge slab of rock is pushed upward between 2 faults, it makes a steep-sided peak called a block mountain. The Tetons in North America are block mountains. How block mountains form. This diagram shows how blocks of rock are pushed upward between faults to form mountains. If a block of land slips down between faults, it forms a deep, flattish valley. This is called a rift valley. Rift valley. Faults. Block mountain. How dome mountains form. Dome mountains form where hot, melted rock pushes up but cools before it reaches the surface. The layered rocks on top are pushed up into a dome shape. Later, the rocks on top wear away to reveal the dome of volcanic rock. Layers of rock. Dome of volcanic rock. Worn smooth. Mountains are slowly worn away by the weather. Over millions of years, high, jagged mountains become lower and smoother. Ben Nevis, left, in Scotland is a very old dome mountain with a rounded top. Did you know? Ben Nevis, the highest peak in Great Britain, is 4,406 feet, 1,343 meters, tall and is part of the Grampians Range in Scotland. The range was once as high as the Himalayas, but has worn down over millions of years. Mount Everest. At 29,078 feet, 8,863 meters, tall, Mount Everest is the world's highest mountain. This famous peak lies in the Himalayas, on the border between Nepal and Tibet in China. The mountain's local name, Shomolunga, means Mother Goddess of the World. Climbing Everest. The first climbers to reach the top of Everest were Edmund Hillary from New Zealand and Tenzing Norgay from Nepal in 1953. Since then, many others have climbed the mountain, although it is difficult and dangerous. Sherpas. Sherpas are mountain people that live in the Everest region in Nepal. These people are used to the cold and are very fit. Some work as mountain guides and others carry loads up the steep slopes. Sherpas balance heavy loads on their backs. Snow covers the bare, rocky slopes of Mount Everest. Sherpa Town. Namche Bazaar is the biggest village near Everest. Sherpas live there. Not long ago the village was tiny, but now climbers and walkers stay there on their way to Everest. Namche Bazaar has become a busy town. Mount Everest facts. The height of Everest was first measured by surveyors in the 1800s. They named it after Sir George Everest, a famous British surveyor. Italian Reinhold Messner was the first person to climb Everest alone and without using bottled oxygen to help him breathe. More than 2,000 people have reached the top of Everest. Did you know? Lhotse, the world's 4th highest mountain, lies very close to Everest. The 2 mountains are linked by a snowy ridge. Cliffs and crags. Rain, wind, and ice can carve mountains into amazing shapes, including steep cliffs, uneven craggy rocks, and tall, rocky pillars. Monument Valley. This valley in the western United States has many craggy, flat-topped rocks. This rock is one of a pair called the Mittens. Can you guess why? Wind and rain have worn away the rock to leave a tall pillar. Devil's Marbles. These amazing rocks are found in the Tinami Desert in Australia. It is very hot there in the day and freezing at night. The heat and the cold make the rocks flake. This has formed rounded shapes that look like giant marbles. Uluru. This mass of sandstone rock in central Australia is called Uluru. The 1,142-foot, 348-meter, tall rock is all that is left of a mountain range that once covered the area. Did you know? Uluru is also called Ayers Rock. It is a holy place for the Aboriginals, the native people of Australia. Dartmoor Tors. Rocky hills called tors are made of a hard fiery rock called granite. Frost and rain crack the rocks and help form the craggy shapes. Many tors are found on Dartmoor in southern England. Mountain habitats. Mountains have extreme weather conditions with long, icy winters. The weather is often windy, rainy, or snowy. Mountain plants and animals have to be tough to cope. Brr. Mountain air is thinner, contains less gas, than air in the lowlands. Thin air can hold less of the sun's heat, so the higher up you climb the colder it gets. People who live on or visit the mountains have to wear warm clothes to keep out the cold. Mountain plants. Different plants grow at different heights on mountains. Trees only grow on lower slopes. At the top, no plants can grow, and snow covers the bare rock. On the middle slopes, there are grassy meadows filled with flowers. Trees do not grow on mountains above a point called the tree line. Snowy peak. Grassy meadows. Tree line. Forest. Mountain animals. Animals that live high on mountains have thick hair to keep them warm. Birds have extra warm feathers. This llama lives in the Andes. Llamas have large lungs that help them breathe the thin mountain air. Moving up and down. Goat-like animals, called chamois, below, live in the Alps. They move up the mountain to eat grass in summer. In fall, they move down to the valley to shelter there throughout the cold winter. Rubbery hooves grip the slippery rocks. Did you know? Animals called marmots live on high mountains in many parts of the world. They stay there all year, spending the winter sleeping in their burrows. This is called hibernation. Mountain dangers. Living in or visiting mountain regions can be dangerous. Sometimes, extreme weather may cause rocks or snow to break loose and roar down the mountain. Landslides. In 2005, houses on this hillside in California were swept away by a landslide. Heavy rain caused chunks of rock on the hillside to become loose and fall downhill. Avalanche. An avalanche is when a mass of snow slips down a mountain. Loud noises or even people skiing can set off an avalanche. The snow gathers speed and roars downhill at up to 185 miles, 300 kilometers, an hour. Preventing avalanches. These fences have been built to protect a village in the Alps from avalanches. The fences keep the snow in place. The danger is greatest when deep snow starts to melt in spring. Mountain rescue. If someone is buried by an avalanche, rescuers have to work very quickly. Dogs can be used to sniff out the person. Then rescuers use spades to remove the snow. Rescue dogs use their good sense of smell to find people buried in avalanches. Did you know? People who are not used to being high up on a mountain can get mountain sickness. They may get a headache and feel sick and dizzy. The cure is to go lower down the mountain. Using mountains. People use mountains in many different ways. Farmers grow crops or rear animals on steep hillsides. Miners dig valuable minerals from the rocks. But most mountain regions have few towns because of the harsh conditions. Farming. Farmers grow crops, such as potatoes and rice, which can cope with the tough conditions. Low walls are built on steep slopes to make flat fields called terraces. Rice is being grown in terraces on this steep hillside. Animals. Farmers rear animals, such as sheep, yaks, goats, and llamas, for their meat, milk, and wool. These animals will graze on slopes that are too steep and stony for farming. Yaks are used to carry heavy loads in the Himalayas. Mountain village. Most mountain villages are built in sheltered valleys, not on windy mountaintops. But extreme conditions can still make life difficult for mountain people. This village is in the Himalayas region of Nepal. Mining in mountains. Gold, silver, and copper are found in some mountains. Miners dig deep tunnels, such as this one in a silver mine, to find the rocks that contain the precious metal. Did you know? El Alto in Bolivia is one of the world's highest towns. It is 13,450 feet, 4,100 meters, high in the Andes Mountains in South America. La Paz, the capital of Bolivia, is the world's highest capital at 11,810 feet, 3,600 meters. Visiting the mountains. Some people visit mountains to enjoy the beautiful scenery and amazing wildlife. Others like to climb the steep mountainsides or ski down snow-covered slopes. Winter sports. Skiing and snowboarding are popular sports in winter. People visit ski resorts, which have safe, snowy slopes and lifts to carry them up the mountain. It takes a lot of practice to become a good skier. Hiking. Hiking is a great way to see fantastic mountain scenery. Some hikers carry a tent and all their food in a backpack. Others stay in mountain huts. These backpackers are climbing in the Pirin Mountains in Bulgaria. Transport. Steep slopes make travel difficult in the mountains. Roads run along the valleys or zigzag up to high passes. Cable cars carry people up very steep slopes or from peak to peak. A cable car to Sugarloaf Mountain, Brazil. Watching wildlife. Some people visit mountains to see wildlife, such as birds or butterflies, or flowers in springtime. Parks have been set up in many mountains to protect rare plants and animals, such as the mountain gorillas in Africa. Tourists watch a mountain gorilla in Congo, Africa. Did you know? Tunnels have been blasted right through some mountains to build roads and railroads. A tunnel under Mont Blanc, Europe's highest peak, runs for about 7 miles, 11.5 kilometers. Icy glaciers. Glaciers are found in high mountains. They are rivers of ice that move very slowly downhill, scraping off pieces of rock as they flow. How do glaciers form? On high mountains, snow does not melt but builds up into a thick layer. The snow underneath gets squashed down and turns to ice. The ice gets so heavy and slippery that it starts to slide downhill. Deep cracks form where the ice splits. At the lowest end of the glacier, the ice begins to melt because the air there is a little warmer. Any pieces of rock carried along in the ice are dumped at the end of the glacier. At sea, the Iceman. In 1991, 2 climbers found the remains of a prehistoric man in a glacier in the Alps. The man had died while on a mountain journey about 5,000 years ago. His body had been preserved by the ice. He was named Ötzi, after the valley where he was found. This is what Ötzi may have looked like. Joining together. Pieces of rock are carried along the sides of glaciers, forming dark stripes called moraines. When smaller glaciers join together, the stripes meet in the middle, as can be seen in the Swiss glacier, right. The Aletsch Glacier in Switzerland is the longest in Europe. Did you know? The world's longest glacier is the Lambert-Fischer Glacier in Antarctica. It flows for 320 miles, 515 kilometers, from the Antarctic mountains toward the sea. Worn by glaciers. Glaciers used to cover much more of Earth than today, see pages 110 to 111. When these glaciers melted, they left scenery shaped by ice, including U-shaped valleys and steep-sided fjords. Sheer sides. This tall, pointed peak was carved by glaciers flowing down all sides of the mountain. It is called the Matterhorn and is found in the Alps in Switzerland. U-shaped valleys. As a glacier flows downhill, it acts like a giant bulldozer. The ice gouges out a deep valley with a flat bottom. Rocks and boulders carried along beneath the glacier scrape away more soil and rock. A glacier carved this deep, U-shaped valley in Wales. Mountain tarns. Small, round lakes called tarns were carved by glaciers. The ice gouged out bowl-shaped hollows high in mountains. When the ice melted, the hollows filled with water. Fjords. Fjords are steep-sided valleys at the coast. They were carved by glaciers thousands of years ago. Later, the ice melted and the sea rose to flood the valleys, creating fjords. A cruise ship visits a steep-sided fjord in Norway. Did you know? Most glaciers flow slowly, moving 3 to 6.5 feet, 1 to 2 meters, a day. The Quarryuk Glacier in Greenland flows much faster, more than 65 feet, 20 meters, a day. Ice caps. In very cold places, the snow never melts. Packed down snow builds up to form a thick layer of ice called an ice cap. In the past, ice covered much more of Earth's surface than it does today. Polar ice. Thick ice covers the land at the Arctic and Antarctic, see page 33. In winter, the icy area gets bigger as the sea freezes over. In summer, the sea ice melts, and the icy area shrinks again. Antarctic ice cap today. Australia, Africa, South America. Arctic ice cap today. North America, Europe, Asia. Old ice. The Antarctic ice cap is up to 2.5 miles, 4 kilometers, deep. The ice at the bottom is made of snow that fell hundreds of years ago. Scientists study the old ice to find out what conditions were like all those years ago. Ice samples, or cores, contain ice from lower layers. Ice ages. During long, cold periods called ice ages, ice covered much of Europe and North America. This map shows the area covered by ice in the last ice age, which ended about 10,000 years ago. Compare this with the map on page 110, showing the Arctic ice cap today. Arctic ice cap 18,000 years ago. Woolly mammoth. Huge, hairy elephants called mammoths lived in Asia, Europe, and North America during the last ice age. Bodies of mammoths have been found in the ice in northern Russia. When the ice age ended, mammoths died out. Did you know? Ice covers about a tenth of Earth's surface today. During the last ice age, it covered about a fourth of the planet. Rivers, lakes, and caves. Rivers are channels of fresh water that flow across the land. Smaller rivers called streams join bigger rivers to make mighty rivers that flow to the sea. Rivers shape the landscape, filling lakes and carving deep caves and canyons. Rivers even flow under the ground. People use rivers and lakes for transport and fun, but these watery places can also be dangerous. Find out more about rivers, lakes, and caves in this chapter. A river's journey. A river's course is the long journey that it takes from where it begins, high in hills or mountains, to where it ends, in the sea or a lake. The source. The place where a river starts is called the source. The water comes from rain or melted snow. It may bubble up out of the ground at a spring or trickle out of a lake or glacier. A stream flows down a mountain. Course of a river. In its upper course, a river rushes down from a hill or mountain, carving deep gorges and valleys. In its middle and lower courses, a river makes wider valleys and creates flat areas called floodplains. Lake. Spring. Upper course. Tributary. Middle course. Lower course. Floodplain. Wearing and shaping. As rivers flow downhill, they carry loose stones and rocks along with them. The stones bounce along the bottom of the river and scrape more soil and rocks away. A bear walks across the rocks and stones left by a mountain river. Joining the river. Trickles of water join to make streams. Streams join to make rivers. Lower down, small rivers called tributaries join the main river. The water gets wider and deeper. Did you know? The Nile River is the world's longest river. It begins in the mountains of East Africa and flows north for 4,160 miles, 6,695 kilometers. The Nile empties into the Mediterranean Sea. Young rivers. At its upper course, a river is known as a young river as it flows downhill. The rushing water loosens rocks and soil, carving deep canyons and gorges. The Grand Canyon. Canyons form where water cuts through hard rock. The Grand Canyon is a famous canyon in Arizona. The Colorado River has worn a very deep valley as it has cut down through the rock. The deep valley of the Grand Canyon. Did you know? The Grand Canyon is up to 1 mile, 1.6 kilometers, deep and 18.5 miles, 30 kilometers, wide in places. Deepest gorge. A gorge is a steep-sided canyon. The Kali Gandaki Gorge in the Himalayas is 3.5 miles, 5.5 kilometers, deep, the deepest gorge in the world. The river has cut a deep valley between two mountains. Leaping salmon. Salmon swim up young mountain rivers to lay their eggs. They have to swim very hard against the flow of water. When they reach fast-moving water, they leap out of the water to move upstream. These salmon are leaping up a waterfall. Foaming rapids. Rapids form where young rivers plunge over stones and boulders. The white, foaming water rushes along very quickly. It is fun to ride the rapids in a rubber boat. Waterfalls. Where a river plunges over a steep cliff, it forms a waterfall. Beautiful falls with white, foaming water can be seen on rivers in many parts of the world. Niagara Falls. Niagara Falls is a famous waterfall in North America. It lies on the border between the United States and Canada. The falls curve around like a giant horseshoe and are 180 feet, 55 meters, high. This boat takes tourists to see the waterfall up close. How waterfalls form. Waterfalls form where water flows from hard rock onto softer rock. The softer rock wears away more quickly to make a shelf. Water gushing over the shelf carves a pool at the bottom. Pool worn by splashing water. Hard rock. Soft rock. Angel Falls. Angel Falls in Venezuela, South America, is the world's highest waterfall. It is 3,182 feet, 970 meters, tall and is located where the Shurin River plunges over a steep cliff. Did you know? Angel Falls is named after American pilot Jimmy Angel, who saw the waterfall from his plane in 1933. Iguazu Swifts. Iguazu Falls is a very beautiful waterfall in South America. It is 2.5 miles, 4 kilometers, wide and drops nearly 330 feet, 100 meters. Small birds called swifts nest on the rock face behind the falls. The birds fly through the water to get to their nests. In the valley. In the middle and lower parts of its journey, the river leaves the hills behind and flows through a wide, flattish valley. Fertile soil. A river carries mud and gravel. After heavy rain, the river may flood and spill muddy water onto the surrounding land, the floodplain. Crops grow well in the fertile soil of the floodplain. A wide river and its floodplain in Colorado. River life. Different plants and animals live in and by the river at each stage in its journey. Herons, such as this one, hunt fish and frogs along the banks of gently flowing rivers. Twisting and turning. Rivers twist and turn as they flow through wide valleys. Water flows fastest on the outside of bends, cutting the bank away. Mud is dropped on the inside, where the flow is weaker. In time, gentle curves become deep loops. River loops are called meanders. Oxbow lakes. Over many years, the loops get bigger and bigger. Eventually, the river cuts right through the loop. The cut-off part becomes a small lake called an oxbow lake. 1. Fastest river flow. River cuts into the outside of bends. Loop. 2. River cuts through the loop. Oxbow lake forms. Did you know? The water in a river is colored by the mud it carries. Mud of different colors can make the water pink, yellow, brown, black, white, or even bright green or blue. Lakes. Lakes are hollows in the ground filled with water from rivers or melted ice. Some hollows were carved by glaciers. Others formed because of movements in Earth's crust. Largest lake. The Caspian Sea is the world's largest lake. It covers 143,250 square miles, 371,000 square kilometers, in Western Asia. Because the lake contains salty water, it is really an inland sea. Caspian Sea. Russia. Kazakhstan. Azerbaijan. Turkmenistan. Iran. Deepest lake. Lake Baikal in Russia is the world's deepest lake. In places, it is more than 5,575 feet, 1,700 meters, deep. This lake is home to the only seal that lives in fresh water, the Baikal seal. Highest lake. Lake Titicaca in Peru is the highest lake in the world on which boats sail. It lies 10,170 feet, 3,100 meters, up in the Andes Mountains. Local people travel in boats such as this one, made of reeds. Crater lakes. Some lakes form when water fills the crater of a volcano. Crater Lake, below, in Oregon is 1,942 feet, 592 meters, deep. It is the deepest lake in the United States. Did you know? The world's largest lake containing fresh water is Lake Superior in North America. It covers 31,660 square miles, 82,000 square kilometers. Reaching the sea. The place where a river meets the sea is called its mouth. The river's flow slows as it reaches the sea, and it drops its load of sand or mud to form flat areas called estuaries or deltas. Deltas. A delta forms when mud or sand builds up at a river's mouth. The delta may be triangular or shaped like a bird's foot. The river divides into many smaller channels as it flows through the delta. The delta of the Mississippi River is shaped like a bird's foot. River estuary. The estuary is the lower part of a river, where fresh water mixes with salty seawater. Worms and snails burrow in the muddy banks, providing plenty of food for birds. Pink flamingos feeding in an estuary. Nile Delta. The Nile River has a huge, fan-shaped delta. Mud dumped by the river has made a triangle of fertile land. Green fields are surrounded by desert, which looks brown. Egypt. Nile River. Nile Delta. Red Sea. Mediterranean Sea. Nile crocodile. In the past, the Nile Delta was home to the Nile crocodile. Now farms cover the delta, and these fierce beasts are rarely seen there. They are still found in rivers, estuaries, and deltas in other parts of Africa. Did you know? The world's largest delta is the Ganges Delta in Asia. It covers 46,600 square miles, 75,000 square kilometers, and has about 250 miles, 400 kilometers, of coastline. The mighty Amazon. The Amazon River in South America is not as long as the Nile, but it contains far more water. The river begins high in the Andes Mountains and flows through the Amazon rainforest on its way to the sea. River basin. Water from an area 10 times the size of France flows into the Amazon. The total area through which a river and its tributaries flow is called the river's basin. Amazon. Amazon Delta. Venezuela. Colombia. Ecuador. Peru. Brazil. Bolivia. Amazon Delta. The Amazon measures about 200 miles, 300 kilometers, across as it reaches the ocean. The river is so wide that it looks like the sea. This picture shows water weaving between islands in the Amazon Delta. Flooded forest. During the rainy season, the Amazon bursts its banks and floods the surrounding forest. This canoe is skimming over what was once the river bank. The floods last up to 6 months of the year. Amazon wildlife. Piranhas are small fish about 6 to 10 inches, 15 to 25 centimeters, long that live in the river. They have razor-sharp teeth and prey on wounded fish and animals that fall into the water. If a piranha loses a tooth, a whole new set grows. Amazon facts. The Amazon flows for about 4,000 miles, 6,450 kilometers. The river and its tributaries cover more than 2.7 million square miles, 7 million square kilometers, more than a third of South America. Every second, the Amazon empties 196,200 cubic yards, 150,000 cubic meters, of water into the ocean. That's enough to fill 75 Olympic-sized pools. Did you know? The Amazon is home to one of the world's largest freshwater fish, the arapaima, which can grow up to 10 feet, 3 meters, long. Underground rivers. Water flows under the ground as well as over it. Water running under the ground can wear away some types of rock to make deep, dark caves. Disappearing water. Water eats into a type of soft rock called limestone. Over time, it makes deep holes called sinkholes and runs under the ground. The water wears away the rock beneath the surface, forming hollow caves. Gaping Gill, a sinkhole in England, is 364 feet, 111 meters, deep. Limestone caves. Water can form huge caves in limestone rock, linked by underground tunnels. Water falling through sinkholes can carve out deep pools. Rock formations called stalactites and stalagmites, see page 130, are often seen in caves. Sinkhole. Stream. Stalactite. Cave. Stalagmite. Pool. Wells. If you dig down deep enough anywhere on Earth, you will reach water. People dig holes called wells and lower buckets down them to bring water to the surface. A boy draws water from a well in Afghanistan, Asia. Desert oasis. Water cannot soak through all types of rock. When it reaches a layer of rock it cannot pass through, water runs sideways. Sometimes the water reaches the surface again and bubbles out in a spring. In a desert, this place is called an oasis. An oasis in Libya, Africa. Amazing caves. In some places on Earth, a secret world lies underground, where caves and tunnels run for miles. Exploring this hidden world is called spelunking. Stalagmites and stalactites. Stalagmites and stalactites are stony pillars found in caves. They are made by dripping water. The water contains a mineral called calcite, which builds up to make the pillars. Stalactites hang down from the ceiling. Stalagmites rise from the floor. Spelunkers. Spelunkers wear waterproof clothes and a helmet with a light on when they explore these dark, wet places. This spelunker is looking at a stalactite. Bat caves. Many bats like dark places. They sleep in caves by day and hunt for food at night. Bats hang upside down from cave walls, using their sharp claws. Cave paintings. In prehistoric times, some people lived in caves. They painted pictures of the animals they hunted on cave walls. This painting in a French cave is more than 15,000 years old. Did you know? The largest group of linked caves and tunnels is the Mammoth Cave system in Kentucky. The caves run for 348 miles, 560 kilometers. Using rivers. Rivers provide water for drinking, washing, and cleaning. People also use rivers to water crops, run factories, and make electricity. No wonder people live near rivers all over the world. Cities on rivers. Most of the world's oldest towns and villages were built by rivers. Some of these are now capital cities, such as London and Paris. The Houses of Parliament, below, in London are next to the Thames River. Water for farming. River water is vital for farming. These green fields by the Nile River are watered by the river. Without the Nile, this place would be a desert. Water for energy. Hydroelectric stations use energy from fast-flowing water to make electricity. A dam is often built to control the flow of water. This is Glen Canyon Dam in Arizona. Did you know? Glen Canyon Dam is 708 feet, 216 meters, high. A huge lake called Lake Powell has built up behind the dam. The lake supplies water to nearby cities. Factories by rivers. Factories of all kinds use river water to power machinery, and also for cleaning. Paper mills, like this one, use huge amounts of water every day. Travel and fun. Rivers have been used by people to travel or move goods ever since boats were invented. Rivers and lakes are also great places to have fun. River transport. Paddle boats, such as this one, have sailed the Mississippi River since the early 1800s. They carry passengers and cargo. This boat is taking tourists on a sightseeing trip. Canals. Canals are human-made waterways. People dig canals to link rivers, lakes, or seas. In Central America, the Panama Canal cuts across a narrow strip of land to link the Pacific and Atlantic Oceans. Huge cargo ships on the Panama Canal. Crossing rivers. In some places, bridges have to be built to carry road and railroad traffic over rivers. This bridge in Bristol, England, crosses the River Avon. Motorists have to pay a fee to use the bridge. Water sports. Rivers and lakes are used for many sports, such as canoeing, sailing, fishing, and windsurfing. This boy is paddling a type of canoe called a kayak. Did you know? The world's longest bridge is the Akashi Kaiko Bridge in Japan. It links two islands and is nearly 2.5 miles, 4 kilometers, long. River safety. Rivers can be dangerous places. Floods can strike after heavy rain, damaging roads and houses. Dirty river water can also harm people and animals. Mississippi floods. In 1993, the Mississippi River burst its banks. Flood water covered more than 17,000 square miles, 44,000 square kilometers. About 70,000 people had to leave their homes. These people are stacking sandbags to try to keep the Mississippi flood water away from their homes. Floods in China. When the Yangtze River in China flooded in 1998, this family escaped by boat. Unfortunately, more than 3,000 people died and about 14 million were made homeless. Did you know? In China, the Yellow River is called China's sorrow because it has caused such bad flooding. In 1938, 90,000 people died when the river burst its banks. Preventing floods. During very high tides, see pages 142 to 143, seawater could flood London. The Thames Barrier was built to protect the city. It has huge gates that can be shut to prevent seawater flowing into the river. Water pollution. River water can be polluted, made dirty, by sewage or waste from farms and factories. This can harm people. Many countries now have strict rules to stop river pollution. This pipe is emptying dirty water into a river. Seas and oceans. The oceans are a vast world that we are still exploring and finding out about. This chapter will explain how waves, tides, and currents affect the ocean and shape the land. It will tell you how coasts, islands, and coral reefs form. You can also find out about the creatures that live at different depths in the oceans, including the deep sea, a mysterious world that we know very little about. Watery world. Only 1/3 of Earth's surface is land. Salty water covers the rest. This huge expanse of water is divided into areas called oceans and seas. Salty oceans. Ocean water is salty because it contains minerals carried out to sea by rivers. The main minerals are sodium and chloride. These two minerals make salt. Oceans and seas. The 5 oceans are called the Atlantic, Pacific, Indian, Arctic, and Southern Oceans. They are linked by smaller areas of water called seas. Warm and cold currents flow like mighty rivers through the oceans. Warm current. Cold current. Pacific Ocean. Atlantic Ocean. Indian Ocean. Arctic Ocean. Southern Ocean. North America. South America. Africa. Europe. Asia. Australasia. Antarctica. Super salty water. The Dead Sea in Asia is 7 times saltier than other seas and oceans. The salt makes the water thicker, so it is easier to float. But all that salt means that nothing lives in the Dead Sea, that's how it got its name. Warm waters. A warm current called the Gulf Stream warms the coasts of Great Britain and Ireland. The current starts near Mexico and flows across the Atlantic Ocean. Palm trees grow in the mild climate on western Irish coasts. Did you know? The Pacific Ocean is the world's biggest ocean. It covers 64 million square miles, 166 million square kilometers, and holds over half of all the water in the oceans. Waves and tides. The water in seas and oceans is always on the move. Waves sweep across the ocean surface. The sea rises and falls on coasts as tides come and go. How do waves form? Winds blowing across the ocean make ripples on the surface. The ripples grow into waves. Far from land, low waves roll across the ocean. Waves get taller as they reach the coast. Beach. Crest. Wave breaking on shore. Circling water. Circling water. The water in a wave moves in a circle. Far out to sea, the water circles freely. Close to shore, the seabed stops water from flowing in circles. This makes the waves rise up into crests. A surfer rides a huge wave. Changing tides. Tides mainly happen because the moon's gravity, see pages 16 to 17, pulls on the oceans. As the moon circles Earth, it pulls the sea toward it. A mound of water forms below the moon, this mound is high tide. High and low tides. These pictures show the same harbour in Cornwall, England, at high and low tides. At high tide, water fills the harbour. At low tide, the harbour is empty, and the boats are stranded on the sand. High tide. Low tide. Did you know? The Bay of Fundy in Canada has very high and very low tides. The water level changes by up to 52.5 feet, 16 meters. Rocky coasts. High cliffs tower above the sea on some coastlines. Other shores have wide, sandy bays, headlands, or amazing rock arches. All of these landscapes are formed by the pounding waves. Steep cliffs. Waves crash onto the shore every minute of every day. Water, grit, and pebbles smash against rocky coasts, chipping pieces away. Steep cliffs form where hills meet the ocean. Headlands and bays. As waves beat against the shore, soft rocks wear away more quickly than hard rocks. The sea cuts deep, curving bays into soft rocks. Hard rocks stand up to the waves, forming headlands that stick far out to sea. Headland. Bay. Rock arch. Rock arches form where waves eat into a headland from both sides. This makes two caves, which eventually wear all the way through to make an arch. This arch is in the Galapagos Islands in South America. How stacks form. Waves continue to crash against a rock arch. Eventually, the top of the arch crumbles, leaving a pillar of rock standing in the ocean. The pillar is called a stack. Arch is worn by the waves. Direction of waves. Arch collapses to leave a stack. Did you know? Waves pound into cliffs and slowly wear them away. On some coasts, the land is worn away by more than 3 feet, 1 meter, each year. On the beach. Beaches can be sandy or pebbly. Most people prefer a sandy beach to any other kind of beach, and some animals do, too. How do beaches form? Rivers carry sand and rocks out to sea. Waves also chip pieces off cliffs. Beaches form where waves dump the sand and rocks in sheltered bays. A sandy beach has formed in this bay in Cornwall, England. Sandy or pebbly. Sand is made of tiny parts of rock or shell. Rivers and waves have smashed the rocks and shells into tiny pieces. Pebbles on beaches are small rocks that have been worn smooth by the water. Beach wildlife. All types of animals live on beaches. Crabs, worms, and cockles burrow into the sand. Gulls search for fish by the water's edge. Shellfish, such as limpets, cling to the rocks. Crabs have large claws, which they use to grab food. Shifting sideways. Where waves strike the shore at an angle, they shift sand and pebbles sideways. This material can pile up out at sea to make a strip of land called a spit. Groins are fences built across a beach to stop the sand from moving along the beach. Spit. Direction of waves. Groin. Did you know? Virginia Beach on North America's east coast is one of the world's longest sandy beaches. It covers more than 300 square miles, 800 square kilometers, of coast. Islands. Islands are areas of land totally surrounded by water. Some islands, such as Great Britain, are big, but many islands are small. There are islands in rivers and lakes, as well as in the sea. Volcanic islands. Islands that lie far out to sea are often the tips of underwater volcanoes. The volcano erupts on the seabed and lava builds up to make a mountain. The mountain eventually breaks the water's surface, forming an island. A volcanic island in Alaska. Near the mainland. Some islands lie close to large land masses called continents. Great Britain was once joined to mainland Europe but became an island when the sea level rose thousands of years ago. Ireland. Great Britain. Europe. Coral Islands. This island is made of a hard material called coral, see pages 150 to 151. Sometimes a ring of coral forms around a small volcanic island. The island may later sink due to movement of Earth's crust, leaving just the coral. A ring of coral. Island life. Many remote islands are home to animals found nowhere else. The giant tortoise lives on a group of islands called the Galapagos Islands in South America. Did you know? Greenland, the world's largest island, covers 850,000 square miles, 2.2 million square kilometers. Small islands may be just a few yards across. Great Barrier Reef. Coral reefs form in warm, shallow seas. They aren't made of rock, but are built from small creatures called coral polyps. The Great Barrier Reef off Australia is the world's largest coral reef. Coral homes. Coral reefs are hard ridges just below the surface of the sea. They are home to many ocean creatures, including colorful fish, shrimp, and starfish. Turtles and sharks swim nearby. Did you know? Coral only grows a few inches a year. It takes millions of years for a large reef to form. Reef builders. A coral polyp has a chalky body and arm-like tentacles. When a polyp dies, its chalky body remains. Millions of bodies build up on top of one another to form a coral reef. Coral tentacles. Reef stingers. Sea anemones live on the reef. The stings of these animals kill most fish, but clownfish are safe because their bodies are protected by a special slime. Scary sharks. Sharks hunt in the clear waters by the reef. These big fish have a very good sense of smell. When they smell the blood of a wounded creature, they swim up for the kill. Pointed fin sticks out of the water when a shark swims near the surface. Barrier Reef facts. The Great Barrier Reef is made up of 2,500 smaller reefs. The reef stretches for about 1,250 miles, 2,000 kilometers, and it is so large that it can be seen from space. More than 1,500 different types of fish live on the Great Barrier Reef. Open ocean. In the open ocean, water stretches out on all sides and for several miles downward. The water can be divided into layers, with different creatures living at different depths. Ocean layers. The upper waters are lit by the sun. Jellyfish and mackerel swim there. Sperm whales and giant squid swim in the dim mid-waters. Gulper eels and anglerfish live in the inky black depths. Sunlit zone, 0 to 650 feet, 0 to 200 meters. Jellyfish. Mackerel. Mid-depths, 650 to 6,550 feet, 200 to 2,000 meters. Sperm whale. Giant squid. Deep sea, 6,550 to 13,100 feet, 2,000 to 4,000 meters. Gulper eel. Anglerfish. Depths below 13,100 feet, 4,000 meters, are called the abyss. Plankton. Tiny plants and animals called plankton float on the ocean surface. These creatures are so small you can only see them using a microscope. Plankton provide food for many larger creatures, including whales. At the surface. Large, powerful fish called marlin chase after the shoals of mackerel on the surface. They snap up the small fish with their long, pointed snouts. Marlin can swim at speeds of up to 50 miles, 80 kilometers, an hour. Diving to the depths. Sperm whales come to the surface to breathe. Then they dive to depths of 3,300 feet, 1,000 meters, to hunt giant squid. Many sperm whales are scarred by battles with squid. Did you know? The ocean's deepest point is the Mariana Trench in the Pacific. It lies 35,827 feet, 10,920 meters, below the surface. In 1961, 2 scientists went to the bottom in a submarine. On the seabed. Many creatures live on the seabed. Starfish and flatfish live in fairly shallow water. Other creatures lurk on the bed of the deep oceans, where there are mountains, cliffs, and volcanoes similar to those on land. Flatfish. Flatfish rest on the seabed. The speckled colors of this place blend in with the sand. The fish changes color when it moves onto rock or weeds, allowing it to hide from its enemies. Ocean floor. Long mountain chains run down the center of the oceans. The flat plains on either side may be dotted with volcanoes or cut by deep trenches. The seabed slopes upward to broad, flat shelves that edge the land. Broad ledge, continental shelf. Sea level. Steep slope. Plain. Seamounts, remains of dead volcanoes. Mountain chain called a mid-ocean ridge. Deep trench. Starfish. Starfish creep along the seabed. Most starfish have 5 arms, but some have up to 20. A starfish can regrow an arm if it is bitten off by an enemy. Mapping the seabed. Scientists map the seabed using a technique called sonar. They aim sound waves at the bottom and listen to the echoes that bounce back. The time taken by the echoes tells them how deep it is. Ship with sonar. Sound waves. Echoes. Did you know? Earth's longest mountain chain is an undersea ridge that runs down the center of the Atlantic. It runs for more than 36,000 feet, 11,000 kilometers, and is called the Mid-Atlantic Ridge. The Deep Sea. The deep sea is the last unexplored place on Earth because it is so difficult to get to. Only a few submarines can descend that deep. Deep sea submarine. This special submarine can explore the bottom of the ocean. It is called Alvin and carries 3 people. Alvin has 2 arms that can collect samples. Black smokers. In 1977, scientists exploring a deep-sea ridge made an amazing discovery. They found strange chimneys spouting clouds of black, boiling hot water. These undersea volcanoes are called black smokers. Fish of the deep. Deep-sea fish hunt in the cold, black water. Many have huge mouths and stomachs that stretch so they can swallow any prey they find. Some can swallow prey twice their own size. Viper fish. Brittle star. Anglerfish. Did you know? Deep-sea fish are built to stand the enormous pressure caused by the weight of all the water pressing down from above. Deep-sea fish can explode if brought to the surface. Life at black smokers. Strange creatures live around the black smokers. There are blind crabs, eyeless shrimp, and long, slim tube worms. The hot water, rich in minerals, helps these creatures to stay alive. A crab near a black smoker. Icy seas. The seas in the polar regions are covered with ice for much of the year. There are towering icebergs and huge, flat-topped ice shelves. When the sea freezes over, a different type of ice, pack ice, forms. Ice shelf. Huge ice shelves edge the land in the polar regions. They form where glaciers meet the ocean, and the ice breaks off and floats out to sea. Penguins. Penguins live on the coasts of Antarctica. They walk with a waddle on land, but are fast swimmers. They dive into the icy water to hunt fish. Penguins cannot fly, but they flap their wings to swim underwater. A thick coat of feathers keeps out the cold. Icebergs. Icebergs form when a large chunk of ice breaks off an ice shelf or a glacier. Icebergs can be a danger to ships. Only a small part of an iceberg shows above the surface, the rest is below sea level. 4/5 of an iceberg lies below the surface. Did you know? The biggest iceberg ever seen had a surface area the size of Belgium. Icebergs can be up to 500 feet, 150 meters, high. Sinking of the Titanic. In 1912, a luxury passenger ship called the Titanic hit an iceberg in the North Atlantic Ocean. The ship sank in just 4 hours, and 1,500 people drowned. The Titanic's owners had claimed it was unsinkable. Ocean treasures. All types of riches come from the ocean. As well as fish and shellfish, there are valuable minerals, such as oil and gas. Harvesting the ocean's riches, however, is often easier said than done. Fishing boats. Fishermen set traps and nets to catch fish and shellfish. Different nets are used to catch fish at the surface and on the bottom. Modern fishing boats catch so many fish that some fish are now rare. Did you know? Many modern fishing boats have refrigerators on board. The fish are frozen soon after being caught to keep them fresh. This allows boats to stay out longer at sea. Pearls. Pearls are valuable gems made by shellfish called oysters. When a piece of grit gets inside an oyster's shell, a hard, shiny ball, called a pearl, forms around the grit. Diving deep for pearls can be dangerous. A pearl diver collects oysters from baskets in Thailand. Oil and gas. Oil and gas are mined from the seabed in shallow waters. A platform called a rig may stand on stilts or float, anchored to the bottom. Engineers drill into the seabed to reach the oil or gas, and then pump it to the surface. Salt. People get salt from the oceans by flooding shallow ponds near the sea with seawater. The water dries in the sun, leaving behind the salt. This salt has been raked into piles. Mysteries of the ocean. The undersea world holds many mysteries and also dangers. In past times, stories of sea monsters helped to explain the dangers. We now understand a lot more about the oceans, but some mysteries remain. The Kraken. Legends tell of a sea monster called the Kraken. The tales said it would trap ships in its tentacles and drag them down to the seabed. Experts believe these stories were based on the giant squid. Rocky reefs. Rocks and sandbanks can be very dangerous for ships, especially in fog or storms. Lighthouses warn ships away from the rocks. In the past, lighthouse keepers controlled the lights, but now most lighthouses work automatically. Myth of the mermaid. In days gone by, sailors reported seeing mermaids. These legendary creatures were said to look like women with a fish's tail. Experts believe the stories are based on sightings of real, seal-like creatures called dugongs. This statue of a mermaid is in Copenhagen Harbour, Denmark. Diving for treasure. In dangerous waters, wrecks of sunken ships lie on the seabed. Some ships sank carrying gold, silver, and jewels. Divers search the wrecks and sometimes bring treasure to the surface. Did you know? In 1872, a ship called the Mary Celeste was found drifting in the Atlantic Ocean. The crew and passengers had all vanished. No one has fully explained this mystery. Air and weather. Weather is created by the sun heating the earth, which makes the air move around. This produces constantly changing conditions, from clear blue skies to gusting winds and deafening thunderstorms. This chapter will explain about air and weather. Find out how clouds form and why it rains. Discover how animals and people cope with different weather. Learn how experts can predict the weather. The atmosphere. Earth is wrapped in a protective blanket of gases called the atmosphere. This blanket makes life possible on Earth. Our weather is created in the lowest layer. Blanket of gases. The main atmosphere gases are nitrogen and also oxygen, which is vital for life. Small amounts of other gases help to trap the sun's heat and filter out harmful rays. Earth's gravity keeps the atmosphere in place. Layers of atmosphere. The atmosphere has 5 layers stacked on top of one another. The lowest, the troposphere, contains about 75% of the atmosphere's gases. The air thins out as you head toward the exosphere and space. 500 miles, 800 kilometers. Atmosphere stretches about 500 miles, 800 kilometers, above Earth. Beyond is space. Exosphere. 300 miles, 500 kilometers. Thermosphere. Mesosphere. 50 miles, 80 kilometers. Stratosphere. Troposphere. 0 miles, 0 kilometers. Did you know? Earth's atmosphere helps protect us from meteors, rocks falling from space. Meteors usually burn up high in the atmosphere, forming shooting stars. Thin air. The higher you go, the less oxygen there is. Mountaineers use bottled oxygen in the thin air to help them breathe. The air on the highest mountains contains about 1/3 of the gases found at sea level. Above the clouds. Clouds form in the lowest layer of the atmosphere. Planes can climb to the next layer, the stratosphere, to get above the clouds and avoid storms. Top of cloud cover. Air. The air in the atmosphere contains a mixture of gases. The constant recycling of these gases links the atmosphere to the living world of plants, animals, and humans. What is air made of? This balloon shows the amounts of gases that make up air. There is almost 4 times as much nitrogen as oxygen. The other gases include carbon dioxide and water vapor. 1% other gases. 21% oxygen. 78% nitrogen. Plant life. Trees and plants use carbon dioxide, water, and sunlight to grow in a process called photosynthesis. They give off oxygen as waste. Nitrogen in the soil helps to nourish plants. Animal life. Living creatures need oxygen to live. When we breathe in, oxygen passes from our lungs into our blood. Blood is pumped all around our body and provides the oxygen we need to live, move, and grow. We breathe out carbon dioxide as waste. Horses breathe in oxygen and breathe out carbon dioxide, just as we do. Breathing underwater. Fish also need oxygen to live. They take oxygen from water, using feathery structures called gills. As water passes over the gills, they filter off the oxygen. This slit leads to the fish's gills. Did you know? The balance of gases in the atmosphere has remained the same for about 1 billion years. Light as air. Air is light. However, the weight of all the air above presses down on you. This is known as air pressure. You can't feel the air pushing against you because the air inside you pushes back. But you can see its effects. Floating and falling. If you drop a ball and a feather, the ball reaches the ground first. Both are pulled by gravity, but the air pushes against the wispy feather more than the smooth, curved ball, so the ball falls faster. Blowing bubbles. When you blow soapy bubbles, warm air from your lungs fills the bubbles. Warm air is lighter than cold air, so the bubbles drift upward. They sink as the air inside cools. Hot air balloon. A hot air balloon climbs high in the sky because a burner heats the air inside the balloon. This makes the balloon lighter than the surrounding air, so the balloon rises. Basket below the balloon carries people. Rising air. When the sun heats a mass of air, the warm air starts to rise. This creates a current of warm, rising air called a thermal. Birds use thermals to glide for hours, hardly flapping their wings. Gulls' large wings help it glide on thermals. Did you know? Hang gliders are like large kites that pilots hang from to fly through the air. They use thermals to rise high in the sky. Wind. Wind is moving air. The wind blows when the sun heats Earth's surface unevenly. Moving air brings different kinds of weather, such as clouds and rain. Why do winds blow? Warm air weighs less than cold air and rises. Cooler air rushes in to fill the space left by the warm air. This movement of air is what makes the wind blow. Wind speed. A wind's strength depends on its speed. A slow wind rustles leaves. A medium wind will make flags flutter. A very fast wind can sometimes uproot trees. You need a strong wind to fly a kite. Using the wind. People use the wind in many ways. Wind turns the sails of windmills. The moving sails turn a grindstone, which crushes wheat into flour. Wind also pushes on the sails of yachts, making them move across the sea. Wooden sail. Did you know? Modern windmills called wind turbines use energy from the wind to make electricity. The sails turn generators, which produce electricity. Weather vanes. Weather vanes, such as this one, turn to show which way the wind is blowing. In most areas, the wind usually blows from one direction. This is called the prevailing wind. Cloudy skies. Clouds are masses of floating moisture. They are made of millions of tiny water drops or ice crystals. Clouds form when warm air containing moisture rises and cools. Fluffy cumulus. If you watch the sky, you will see clouds of different shapes. Different clouds bring different types of weather. White, fluffy clouds known as cumulus usually mean fine weather. Cumulus clouds drift across the sky in summer. Storm clouds. Cumulonimbus clouds are towering, flat-topped clouds. If you see these clouds, watch out for bad weather. They often bring heavy rain, hail, or thunderstorms. See pages 202 to 203 and 210 to 211. Flat-topped cumulonimbus clouds. Wispy cirrus. Cirrus clouds form very high in the sky. They are made from ice crystals. The wind sometimes blows these white clouds into wispy shapes, such as horses' tails. Did you know? Cirrus are the highest clouds. They form 3 3/4 to 7.5 miles, 6 to 12 kilometers, up in the sky. Cumulonimbus clouds are very tall and can tower up to 5.5 miles, 9 kilometers, high. Thick stratus. Stratus clouds are low-level clouds. Sometimes they cover the whole sky in a thick gray blanket. These clouds may bring drizzle, rain, or snow. Thick, gray stratus clouds. It's raining. Sooner or later, clouds shed their moisture as rain, snow, sleet, or hail. This is called precipitation. Very fine rain is called drizzle. A short burst of rain is called a shower. Rain from ice. In very high clouds, the moisture forms ice instead of water. Tiny ice crystals join up to make snowflakes. Snowflakes often melt on the way down to fall as rain. Rainstorm. Tiny drops of water in clouds join together to make bigger drops. When the raindrops become too heavy, they fall to the ground. A very heavy shower is called a cloudburst. The sky turns gray when the clouds become thick. Rainbows. If the sun comes out when it's raining, you may see a rainbow. Raindrops bend the different colors in white light, separating them out into red, orange, yellow, green, blue, indigo, and violet. Keeping dry. A raincoat and rubber boots will keep you dry in wet weather. An umbrella will keep you extra dry. They are all made of waterproof materials that keep out the rain. Did you know? Raindrops are not shaped like teardrops. They are round with a flatter top and bottom, like hamburger buns. The water cycle. Moisture moves between the air, oceans, and land in a never-ending cycle. As the water moves around, it changes from a liquid into a gas and back again. Powered by the sun. The sun powers the water cycle by warming the air. Warm air holds more moisture than cold air. When warm, moist air cools, clouds form and bring rain. Sun. 1. Moisture rises into the air. 2. Warm, moist air blows inland. 3. Clouds form as warm air rises and cools. 4. Rain falls from clouds and runs into rivers. 5. Rivers drain into the sea. Did you know? The rain that falls where you live has fallen many times before in other places. No new water forms on Earth, it is just recycled naturally. Rising moisture. As the sun warms the sea, moisture rises into the air in the form of a gas called water vapor. This process is known as evaporation. Winds blow the warm, moist air toward the land. Clouds form. When warm, moist air rises over hills or mountains, it cools. The water vapor turns into tiny drops of water or ice, which gather to make clouds. The clouds bring rain, snow, or hail. Soaking up water. When it rains, some water drains into rivers and travels back to the sea. Rainwater also soaks into the ground. Trees draw up moisture through their roots and release it through their leaves. Dew, mist, and fog. Dew, mist, and fog all form when moisture in the air collects into water droplets. This happens when the air cools suddenly, for example when it blows over a cold surface. Dew. Dew forms on thin, cold surfaces in the morning or evening. As the surface cools, moisture from the air collects on it. When it's very cold, the dew becomes frost. Water appears on leaves as dew drops or frost. Mist. Mist is low cloud that touches Earth's surface. Mountains are often misty because the air is colder there. Llamas roaming in the misty Andes Mountains in Peru. Did you know? Mist usually forms at the tops of mountains. However, certain conditions can make mist form in the valley below, leaving the mountain tops clear. Fog. Fog is thick mist, where you can see less than about 1/2 mile, 1 kilometer, ahead. Fog can be dangerous. Drivers have to use bright fog lights and be careful when driving. Smog. Smog is a dirty haze of smoke and fog that hangs over cities. It forms in air that has been polluted by fumes from cars and factories. People who live in smoggy cities can have trouble breathing. Deserts and drought. Some parts of the world get more rain than others. Deserts are places where almost no rain falls. Some deserts lie near the center of continents where the air is very dry. Desert plants. Cactus plants can grow in dry places. They store water in thick stems. Saguaro cactuses, such as this one, can grow up to 56 feet, 17 meters, tall and live for 200 years. Sharp spikes keep predators away. Drinking dew. Reptiles, such as snakes and lizards, are common in deserts. This lizard, called a thorny devil, lives in Australian deserts. The spines on its body channel dew toward its mouth for drinking. Spines also protect the lizard from enemies. Desert in bloom. When rain finally falls in the desert, seeds sprout and plants bloom quickly. For a few days, the desert becomes a carpet of flowers. But the flowers soon wither as dry weather returns. Did you know? The Atacama Desert in South America is the driest place on Earth. Some parts have had no rain for centuries. The Andes Mountains shield this region from the wet ocean winds. Drought. A drought is a long time without rain. Some parts of Africa are regularly hit by drought. Crops and animals can die of thirst. People may have to move somewhere else until it rains. The Sahara Desert. The Sahara Desert, which stretches across North Africa, is the world's largest desert. Plants, animals, and people have to be survival experts to live in this harsh place. Sand dunes. About 1/5 of the Sahara is covered in sand. The rest is covered in stones. The wind blows the sand into high hills called dunes. Saharan sand dunes look red at sunset. World's biggest desert. This map shows the size of the Sahara. It stretches from the Red Sea to the Atlantic Ocean. The Sahara is actually getting bigger, as farmlands on the edge are hit by drought. Europe, Asia, Africa, Sahara Desert, Red Sea, Atlantic Ocean. Camels. In the Sahara, camels are used as pack animals. They carry goods and people across vast stretches of desert. When food is scarce, these tough animals live off the fat stored in their humps. Broad hooves stop the camel sinking into the soft sand. Did you know? Camels can survive for many days without water. On reaching a water hole, they can drink 26 gallons, 100 liters, in a few minutes. That's as much as a bathtub full of water. Desert people. Some people in the Sahara are nomads. They wander from camp to camp, sleeping in tents and leading their camels in search of food and water. Today, many desert nomads have settled down to live in towns. Sahara facts. The Sahara is 3.5 million square miles, 9 million square kilometers, an area the size of the United States. About 6,000 years ago, the Sahara was much wetter. Cave paintings show that elephants and giraffes once lived in areas that are now desert. The Sahara's tallest dunes are 1,525 feet, 465 meters, high. Living with the weather. All over the world, people have learned to cope with local weather conditions. The right clothes and the right type of home can keep people comfortable in scorching heat, bitter cold, or heavy rain. Dressed for the cold. Some parts of the world have harsh winters with months of snow and ice. People dress in warm clothing when they go outside. Homes are cozy and well heated. Furry hood and fleece jacket keep out icy winds. Ready for floods. In regions that get heavy rain, flooding is common. In parts of Asia, some homes are built on stilts to keep them dry during floods. Small boats are used to travel about. Stilt houses have steep roofs that shed the rain. Cave homes. In deserts and places near the equator, the fierce heat can make life very uncomfortable. In parts of Africa and Australia, people keep cool in homes dug out of rock. Hibernating animals. Animals have their own ways of dealing with harsh weather. Mammals, such as this groundhog, spend the winter months in a deep sleep called hibernation. Sleeping saves energy when food is scarce. A hibernating groundhog. Watching the weather. Weather plays a big part in our lives. It affects how we dress and whether we plan to be inside or outside. Knowing about the weather is especially important to farmers, sailors, and anyone who works outdoors. Weather balloon. Weather balloons measure conditions high in the atmosphere. They rise because they are filled with a light gas called helium. Aircraft and satellites also make records and watch out for storms. Weather balloons send information by radio. Weather stations. Weather stations all over the world measure rainfall, wind direction and speed, and air temperature, how warm or cold it is. These records are fed into computers, which help to work out what the weather will do next. Did you know? Weather stations aren't only found on land. They can also be ships at sea, floating buoys, or satellites in space. Weather stations file thousands of weather reports every day. Weather forecasts. Weather forecasters tell us what the weather will be like over the next day or so. They use symbols on maps to show the likely conditions, such as temperature, wind, sunshine, and rain. Key. Sun. Cloud. Rain. Temperature. Wind. Keeping a daily record. You, too, can become a weather expert by keeping a daily weather record. Record temperature and rainfall by using a thermometer and a measuring jug. Wild weather. Most places on Earth are sometimes hit by severe weather, such as hurricanes, tornadoes, thunderstorms, hail, and heavy snow. This chapter explains the causes of wild weather, including how hurricanes form and why storm clouds produce hail or lightning. Experts say the world's weather is getting warmer and wilder. Read on to find out why and how we can take care of the Earth. Hurricanes. Huge spinning storms with powerful winds are called hurricanes. The winds whirl about a calm eye in the center. Hurricanes form over warm oceans and cause damage when they hit land. How do hurricanes form? As the sun heats the ocean, warm, moist air rises to form thunderclouds. Cold air rushes in at the bottom. The thunderclouds merge and start to spin. Direction of spin of hurricane. Strongest winds are around the eye. Warm, moist air rising. The inside of a hurricane. Air spirals around the eye and cools. Whirling clouds. This picture of a hurricane was taken from space. It shows bands of clouds swirling around the eye in the center. Hurricanes are enormous, they can measure 300 to 500 miles, 500 to 800 kilometers, across. Powerful winds. Hurricane winds blow at more than 185 miles, 300 kilometers, per hour. Whole trees can be uprooted. It is very dangerous to be outside in a hurricane. Hurricane damage. When hurricanes hit land, roaring winds can destroy homes and other buildings. These storms also bring heavy rain and can cause floods. Did you know? Fierce storms are called hurricanes if they form in the Atlantic Ocean. If they form in the western Pacific, they are called typhoons. Hurricane Katrina. In 2005, a powerful hurricane called Hurricane Katrina struck the southern United States. The coastal city of New Orleans was badly flooded. It was the most destructive storm that has ever hit the United States. Wrecked towns. Hurricane Katrina wrecked seashore towns when it blew in off the ocean. Powerful winds tossed this truck into a tree. Boats were sucked out of the sea and hurled onto the shore. Rising waters. Roaring winds, rough seas, and heavy rain caused flooding. The Mississippi River spilled over high banks called levees that had been built to prevent flooding. Water poured into the nearby city of New Orleans. Flood waters burst through a levee. Boat rescue. City leaders ordered everyone to leave New Orleans. Helicopters and boats rescued people who had been stranded in their homes by the rising flood water. Returning home. When the water finally drained away, the levees were rebuilt. Damaged buildings then had to be repaired. It was a long time before it was safe for people to return to their homes. This family moved back a year later. Katrina facts. Winds up to 174 miles, 280 kilometers, per hour were recorded during Hurricane Katrina. Flood water covered 4/5 of New Orleans. Homes, stores, and parks were covered by up to 20 feet, 6 meters, of water. Did you know? During Hurricane Katrina, more than 1,000 people died. About 1 million homes were damaged by the high winds and flooding. Tornadoes. Tornadoes are small but very violent storms. A whirling funnel of air weaves across the landscape, sucking up debris. Tornadoes form on land, not out at sea. Inside a tornado. Tornadoes are much smaller than hurricanes, usually less than 1/2 mile, 1 kilometer, across, but the winds inside whirl even faster. As in a hurricane, the winds spiral around a calm central eye. Spinning funnel of air. Air descending from cloud. Touchdown. In hot, sticky weather, warm, moist air shoots upward to form towering thunderclouds. A funnel of whirling air appears below the cloud. It forms a tornado when it touches the ground. Twisting funnel can tower up to 650 feet, 200 meters, high. The tornado does a lot of damage where it touches the ground. Hit by a tornado. The super strong winds of a tornado have tremendous power. But the path of destruction is usually narrow. A tornado may completely wreck one house but leave the next one untouched. The damage caused by a tornado in Florida in 2007. Tornado Alley. Tornadoes are most common in the United States. Each year, the country has about 1,000 tornadoes. Most form in an area called Tornado Alley, colored yellow on this map of the United States. Tornado Alley. Gulf of Mexico. Did you know? Winds of about 373 miles, 600 kilometers, per hour have been recorded inside tornadoes. These are the fastest winds on Earth. Tornado damage. Tornadoes travel only a short distance before dying out. But they leave a trail of destruction. Sometimes a whole group of tornadoes forms at once. This is called a tornado outbreak. Tornado outbreak. In 1974, 148 tornadoes formed in a single day in the United States. The funnels swept across 13 states, as shown on the map. They killed 330 people and left a path of devastation 2,500 miles, 4,000 kilometers, long. Canada, United States of America, Michigan, New York, Illinois, Indiana, Ohio, Kentucky, West Virginia, Virginia, Tennessee, North Carolina, Mississippi, Alabama, Georgia. Tornado shelters. When a tornado strikes, the safest place to be is underground. Many homes in the United States have underground shelters in basements. People hide if they are told a tornado is due and come out when the danger has passed. Freak damage. The funnel of a tornado acts like a giant vacuum cleaner. It can suck roofs off houses and flatten buildings. It can pick up cars like toys and toss them into the air. Storm chasers. Most people will do anything to avoid a tornado. But experts called storm chasers enjoy watching tornadoes up close. When a tornado is reported, they race to the scene to photograph the storm. Did you know? Tornadoes have been known to pick up heavy objects. In 1931, a tornado lifted a train weighing 80 tons, 88 tons, whirled it through the air, and threw it into a ditch. Freak storms. Hurricanes and tornadoes are not the only spinning storms. Whirlwinds can form over the sea or whip up sand in deserts. These storms are usually small but scary. Dust devils. Small tornadoes that form in deserts are called dust devils. The swirling air picks up sand and carries it up to 100 feet, 30 meters, in the air. Despite their name, dust devils don't usually do much harm. Cloud of sand picked up by a dust devil. Waterspouts. When a tornado strikes at sea, it forms a waterspout. The narrow, twisting funnel sucks up water and sometimes fish, too. If the waterspout moves on to the land, it may dump a shower of fish. Funnel of whirling clouds hits the sea. Shower of frogs. Over the centuries, there have been many reports of animals or strange objects dropped by whirlwinds. In 1939, a shower of little frogs fell on a town in western England. Swirling winds had sucked the young frogs out of ponds. Sandstorms. High winds can whip up sandstorms in deserts. Stinging sand fills the air, and people run for shelter. Wind can carry sand for thousands of miles and then dump it far away. A sandstorm in Pakistan has turned the sky orange. Did you know? In 1940, a shower of silver coins fell on the Russian town of Gorky. A whirlwind had carried off a hidden treasure chest, which then burst open, scattering coins. Thunderstorms. About 2,000 thunderstorms rage somewhere on Earth every minute. These storms can cause terrible damage. They usually happen in hot weather, when warm, moist air rises to form thunderclouds. What is lightning? Swirling air in thunderclouds makes raindrops rub together. This produces tiny electric charges. Positive charges build up at the top of the cloud, negative charges build up at the bottom. Lightning sparks between the two. Ground below also has a positive charge. Negative charges. Thundercloud. Lightning. Positive charges. Static electricity. The type of electricity that builds up inside thunderclouds is called static electricity. This is the same kind of electricity that makes your hair stand on end if you brush it hard. Thunderclap. As lightning streaks through the sky, it heats the air to incredibly hot temperatures. The air explodes, causing a deafening crack of thunder. Light travels faster than sound, so you see the lightning before you hear the thunder. Did you know? The sound of thunder takes 5 seconds to travel 1 mile, 1.6 kilometers. You can tell how far away a storm is by counting the seconds between the lightning and thunder and dividing the number by 5. Forest fires. Lightning can start forest fires, especially in dry weather. In 1988, fires caused by lightning raged through Yellowstone National Park. Many thousands of acres of forest were burned. Streaks of lightning. Lightning is a huge spark of electricity. It can take different forms, depending on whether the spark flashes between clouds in the sky or shoots from a cloud to the ground below. Sheet lightning. When lightning flashes between clouds, it produces sheet lightning. The sparks light up the clouds from inside, so they glow, as above. Forked lightning. When lightning leaping downward splits into many branches, it is called forked lightning. Lightning flashes downward because the ground below has developed a positive charge. Forked lightning hits a town in Utah. Lightning strike. Lightning always takes the fastest route to the ground. Sparks are attracted to tall objects, such as trees and high buildings. For this reason, people should never shelter under a tree in a storm. Lightning rods. Tall buildings are often struck by lightning. A lightning rod makes the building safer. Lightning strikes the rod and then runs safely down a wire into the ground. Lightning hits the lightning rod on a tall building in Shanghai, China. Did you know? Being hit by lightning can be deadly. But some people survive, including champion golfer Lee Trevino, who was struck during a game. Monsoon and floods. In some parts of the world, winds called monsoons change direction in different seasons. Summer monsoons bring heavy rain, which can cause flooding. Summer rain. Farmers rely on the monsoons to water their crops in summer. These farmers in India are planting rice during the monsoon rains. Changing winds. This diagram shows how monsoon rains in Asia change direction. In winter, winds blowing south from the mainland bring dry weather. In summer, winds blowing north off the ocean bring heavy rain. Key. Winter. Summer. Pakistan. India. Bangladesh. Indian Ocean. Hit by floods. Monsoon rains often cause floods in Bangladesh, a low-lying country next to India. Water flooded this village in Bangladesh after a heavy monsoon in 2007. Storm surges. As a hurricane moves over the sea, it sucks up water. The mound of water, called a storm surge, causes flooding when it hits the coast. Flood water covered this American coastal town following a hurricane in 2003. Did you know? In 1900, the port of Galveston, Texas, was wrecked by floods during a hurricane. A wall of water swept right over the town as the hurricane hit. Snow and frost. In many parts of the world, winter brings frost, ice, and snow. If you wrap up warm, this wild weather can be a lot of fun. Snow. Snow forms in clouds where the air is below freezing. The moisture in the clouds turns into ice crystals, which join to make snowflakes. Snow is good for going sledding. Snowflakes. All snowflakes have 6 points or 6 sides. No two flakes are the same shape. A scientist studied snowflakes for 50 years without ever finding two that were exactly alike. Frost. In freezing weather, ice crystals form on leaves, windows, and other cold surfaces. We call these crystals frost. Thick frost can look like a coating of snow. Icicles. Icicles may hang from roofs, trees, and cliffs in cold weather. They form when water starts to drip and then freezes. As more water trickles down and freezes, the icicles grow longer and longer. Did you know? Paradise in Mount Rainier National Park is one of the world's snowiest places. One year, 105 feet, 32 meters, of snow fell on Paradise. Hail and blizzards. Extreme winter weather can be dangerous. When heavy snow combines with strong winds, we call it a blizzard. Hail is when pellets of ice fall from the clouds. Snowstorms. Swirling snow fills the air during a blizzard, and a layer of ice makes roads slippery. Roads can be blocked by the heavy snow. Drivers cannot see far in a blizzard, which makes driving dangerous. How hail forms. Hailstones form when winds toss ice crystals up and down inside cold clouds. As the ice crystals rise and fall, more layers of ice are added, forming pellets of ice called hailstones. These hailstones eventually get so heavy they fall to the ground. Hailstones are tossed up and down inside the cloud. Heavy hailstones fall to the ground. Hail damage. Large hailstones do a lot of damage. Hailstones the size of baseballs can dent car roofs and smash windshields. They can also flatten crops. Most hailstones are about the size of a pea, but some can be much bigger. Did you know? The largest hailstone ever recorded fell on Aurora, Nebraska, in 2003. The giant lump of ice was 7 inches, 17 centimeters, across. Clearing snow. This snowplow is clearing a snowy road. Snow piles up on rooftops and branches during a blizzard. Trees, roofs, and even power lines can collapse under the weight of snow. The plow blade pushes the snow out of the way. Changing weather. In recent years, wild weather has become much more common. Experts say that this is because the world is getting warmer and that harmful waste called pollution is to blame. Global warming. Power stations burn coal, oil, and gas to provide energy. But they also release waste gases into the air. These gases are making Earth warmer. This is called global warming. Greenhouse gases. Gases in the atmosphere trap some of the sun's heat. They act like the glass in a greenhouse, so they are called greenhouse gases. Pollution is adding more of these gases into the air, and this is making Earth warmer. Some of the sun's heat is trapped by gases in the atmosphere. Atmosphere. Sun. Earth. City pollution. Cars give off greenhouse gases. The air in cities is polluted by fumes from cars and factories. Cities cause a lot of pollution because so many people live there. Cars pump waste gas into the city air in Shanghai, China. Melting ice sheets. Global warming is melting the ice in the polar regions. Melted ice is adding to the water in the oceans, making sea levels rise. This polar bear will have nowhere to hunt if all the ice melts. Did you know? Temperatures rose by about 1 degree during the 20th century. Experts believe Earth may start to heat up more quickly if we don't reduce pollution now. Caring for Earth. Global warming is making sea levels rise. It is also causing more wild weather. We need to find ways of reducing the pollution that is making Earth become warmer. Rising seas. If sea levels carry on rising, cities by the coast could flood. Beautiful islands, such as the one above, could disappear. We need to produce less pollution to stop this happening. Waves could flood this island in the Indian Ocean if sea levels rise. Cycling. Car journeys cause a lot of pollution. We can produce far less pollution by choosing different ways to travel. People should try to walk, cycle, or take the train or bus to work or school. Recycling. Waste paper, glass, metal, and plastic can be collected and sent to factories to be made into new materials. This is called recycling and helps to save energy. A box of waste ready to be recycled. Saving energy. Power stations that provide us with electricity are adding to global warming. We can help by using energy more carefully. People should switch off lights, televisions, and computers when they are not being used. Did you know? Energy from the wind, sun, and flowing water can be used to make electricity without causing pollution. These forms of energy are kind to Earth. The end.